members and everyone here in this room. A very good morning to all of you and welcome to the Community Resilience Shelter Division. In India, the National Disaster Management Authority oversees disaster resilience through mitigation, response, recovery, and reconstruction. However, efforts often focus on response after disasters, strike with a limited emphasis on proactive risk reduction. The finalist teams have worked hard to change this, analyzing community vulnerabilities and proposing solutions that are collaborative, innovative, and sustainable. I'm thrilled to invite you all here for their presentations in the Community Resilience Shelter Division to see their impactful ideas in action. My name is Srijit Jairam, and I work with Saint Gobain Research India, and I'm going to be the MC here for today. And it's my job to keep us all on time, so I'll be taking that very seriously. So our finalist teams have put in a lot of hard work. They've submitted their project reports about a month ago, and our jury have, and the teams will present their work to the jury today. So teams, instructions for you, you'll have 20 minutes for your presentations. That is followed by a 10-minute Q&A. And there will be a 5-minute transition period that will happen. And you should use that 5 minutes to move your component model out so that the next team can come in and place their model. The Community Resilience Shelter Division has 3 jury members who have expertise in net zero and resilient buildings. First, we have Piyush Seksaria, who's an independent consultant, natural resources and disaster risk management. Hi, Piyush. The next jury member is Shaili Goswami. She's the tech lead for building science R&D with Saint Gobain Research India. Hi, Shaili. And lastly, we have our third jury member, who's Isaac Emmanuel, who's the professor of practice. Hi, Isaac. So these 3 jury members have had 3 weeks to review the reports that you submitted, that the teams have submitted. They've looked at your work in detail. They've already assessed the 10 contest areas of the decathlon. And today, your presentation will help them understand your narrative better. So they will assess your presentation and mastery over your solution through the Q&A session. So they may revise their scores that they've already given or based on what they hear from you today. So jury members, I'm excited to have you meet the teams today. And I'll need to keep interrupting people from time to time, including you. So that is to keep us all on time and make sure that the session goes smoothly. So please keep your comments and questions direct. So if you're ready to begin, let's start with that. So are we all ready to begin? It's not loud enough. Yes. Yeah, cool. Okay, so let's start with the first presentation. So for our first presentation, we have team Zaranyu, who have worked on Project Dhruva in Assam. So team, please take the stage. "20 minutes to present your work to the jury members. At 15 minutes, I will ring a bell like this, and you won't have a 21st minute. So at the 20th minute, I'll have to stop you and ask you to end your presentation. After that, we'll do a 10-minute Q&A with the jury members, so keep your answers direct and to the point. So the team, the stage is yours. All the best." Yeah, and your time starts. Yeah, can you load the, yeah. Right. So now your time starts right now. Yeah.
Hello, I am Ayushi. This is Ritvik, Khushi, and Leelashri. We are here today to represent Team Zaranyu. Today, as we stand here comfortably in this room, I want you to think of Assam, through which flows the mighty yet unpredictable Brahmaputra River. Now, imagine waking up to the sound of rushing water, not from a faucet, not from a river, but from beneath your floor. Children navigating flood waters just to reach safety. This is not a scene from a movie. It's the reality for thousands, where homes, schools, and lives are washed away. Year after year, 2008, 2012, 2017, 2020, it keeps happening. We didn't want to just design for people, we wanted to design with them. So we spoke to a few families to understand their point of view, and this is what they had to say.
সেইদিনা ৰাতি যেতিয়া পানীৰ কোবাল সুদ ভিতৰলৈ সোমাই আহিছিল
মানুহবোৰ ইটোৰ গাৰ ওপৰতে সেইটো ক'ব লগা হৈছিল আমি নিজৰ ঘৰতে আছিলোঁ কাৰণ যাবলৈ আৰু বেলেগ ঠাই নাছিল
These conversations helped us identify three major problems, but the main question remained: what can we do about it? Good morning, jury members and every individual present over here. We are Team Zaranyu, and our vision is to embrace culture, respond to climate, and have the courage to do things differently. We are proposing a flood resilience shelter, and one that is usable every day but transforms during floods. And now we have identified the challenges and shape our design objectives further accordingly. Meet Team Zaranyu, 14 students from Mahe, Manipal, with the backing of Pragya India, supported by industry partners and faculty advisors. Nestled along one of the major tributaries of the Brahmaputra, falling under seismic zone 5 and extremely prone to floods, we identified Badoti Miri in Lakhimpur district of Assam. The site is 1,307 meters square. The agricultural fields stretch closer to the riverbanks, putting both homes and livelihoods at constant risk. Before starting the design development, we dive deep into social cultural analysis to understand aspects like demographics, livelihood, and infrastructure access. Understanding the mapping and analysis of the hydrological map showed us a maximum rise of 3.4 meters in water levels during flood. We'll get back to how important this data was for us in our structural strategy and planning. Key takeaways and design decisions from SWOC were to provide a pile foundation in response to a sandy, loamy soil condition on site, intervene on site level due to the unfavorable slope pattern, and plant trees to increase the water retaining capacity of soil. Starting with the site level zoning, services were zoned towards north so that it benefits from prevailing wind for passive aeration and eliminating odor near living areas. The root zone treatment plant is placed near to the washing closet and pantry for easy access to organic waste and to reduce long pipelines. All the services are surrounded by vegetation to enhance percolation and natural filtration. In terms of site level intervention, to increase resilience, water dikes are positioned towards the east to slow down the water from the river, further channeling it via water channels along the periphery of the building. The form development of the CRS began with a simple rectangular block to complement the shape of the site so that we can take maximum advantage of the floor plate. Then it was divided into two volumes, namely the shelter block and the service block, to ensure privacy. The blocks were staggered to create voids so that we could take advantage of prevailing winds to create stack ventilation, cross ventilation, and ample sunlight. Moving on, the building level zoning was done according to an emergency-driven hierarchy with three main spaces. The shelter block and doctor's accommodation are positioned next to each other for immediate access during crisis. Services such as the cattle shed and grain storage are placed towards southwest to reduce disturbance and streamline logistics. The west side of the building exposes the deck and emergency staircase zoned to facilitate safe and easy evacuation via boats or by feet. The decks also double as a shading device, protecting interiors from the harsh western sun and breathable flood zones. Now that we're done with the basic planning, let's take a walkthrough. The entry to the site is on the longer side towards east, adjacent to the main road. As we move along the front, the facade reveals artwork inspired by Assamese Japi motifs, a nod to local heritage. The railings are interwoven with jute ropes, not just as a craft reference, but as functional elements, offering grip and resilience, especially during Assam's heavy rains. As we move on to the first floor, you'll notice the modular bunk beds made from bamboo, which combine multifunctionality and resilience. Featuring mortise and tenon joints for strength and earthquake resistance, let's take a look at how it functions. The beds are arranged around an octagonal cutout, which doesn't just create a natural circulation space, it becomes a playful social core. Along the outer walls, we have added chalkboard panels where kids can doodle, adults can write messages, or maybe someone can finally win a tic-tac-toe, with, of course, a safety net. We've used movable screen partitions for added privacy and flexibility in spaces like emergency rooms and storage areas. The terrace garden on the third floor offers a peaceful space promoting mental well-being and a sense of normalcy during crisis. From stack ventilation and deep verandas to thatch insulation and bamboo composite walls, we have covered resilience in every layer through passive strategies. This is just how the building functioned in one of the ways. From macro to micro, every part is built to serve dual roles, one for everyday use and one for when the floods hit. The cattle areas become grain distribution areas, and the shelter spaces become cultural art zones. Now, rewinding to our analysis, from our socio-cultural analysis, we identified the need of a vocational training center. This conceptual training calendar ensures the space teaches, empowers, and earns relevance even in peacetime.
But Ayushi, numbers matter, right? Coming to the health and well-being part, our passive strategies in the structure allow ample daylight levels, as in the simulations, making reading, writing, day-to-day tasks, even complex tasks, simpler. CFD simulations show that cross-ventilation and stack effect have a positive value, as 0.16 meter per second of fresh airflow is achieved. Air changes per hour is 3.6 times per hour, eliminating need of mechanical ventilation system entirely. A steady operative temperature of 22 degrees Celsius to 29.5 degrees Celsius is achieved through these strategies, along with the relative humidity levels of 59 to 71%, making it a low impact and a healthy environment. 520 kilograms per month to 640 kilograms per month of CO2 emissions is observed in the structure, therefore keeping it clean and safe for living standards. Coming to the topic of energy performance, our structure has achieved an excellent EPI of 11.1 kilowatt hour per meter square year, and that has been made possible through various energy conservation measures. Creating a high performance envelope has been one of our major ECMs, with different material usages observed. The proposed material U values over the base case are wall with a 0.428 watt per meter square Kelvin, floor 1.957 watt per meter square Kelvin, and roof is 0.65 watt per meter square Kelvin. A window to wall ratio of 40% has been achieved after running multiple simulations of different WWR ratios in Design Builder and then comparing that data. We have also used shading devices and two different glass systems for conventional windows and clerestory windows, with a U value of 3.8 watt per meter square Kelvin and 5.0 watt per meter square Kelvin respectively. Efficient electric fixtures are implemented with the proposed case following BEE star rating standards. A grid of electric energy is implemented where yearly unused energy of approximately 7,000 kilowatt hour is returned back to the grid. 48 solar panels generate 34,900 kilowatt hour approximate energy per year. And a collaboration with Greeneria and their biogas product helps generate approximately 8,300 kilowatt hour energy per year. This is how we have thought out the breakdown of two systems that are used to generate energy in our site. Coming to the topic of embodied carbon, we have assumed base case scenarios for material usage, where the following values have been achieved through locally sourced materials from the nearest city, which is Jorat. And this has led to the reduction of percentages of embodied carbon as follows. Wall, with a reduction of 107.3%. It has a mixture of bamboo panels, thatch insulation, and clay lime plaster. Roof, with 75.16%, which uses bamboo mat corrugated sheets. Floor, 93.114% with use of straw and cork insulation. Fenestrations, 96.64% with use of bamboo framing and single glazing windows. And structural systems with 48.1% reduction, which uses recycled steel framing.
Now coming to the aspect of water, during an average day, our daily water consumption is around 11,385 liters, while during monsoon, it goes up to 27,000 liters when people are in the flood scenario. To address the needs of the building, we use an integrated rainwater harvesting system over a catchment area of 1,220 square meter of the built structure, yielding up to 3.74 lakh liters of water in just 1 month. Grey water filtration further supplements domestic demand, especially in months with low rainfall. The rest of the required water during those months is covered by the wells, which are at least 2.8 meters deep, which hit the groundwater table during the dry season itself. We've implemented efficient saving methods such as ultra-low flow fixtures, root zone treatment, composting toilets, smart metering, and saving nearly 7.89 lakh liters per month. Overall, through all these methods combined, we aim to use water efficiently, and extrapolating from there, we will be able to reduce monthly water usage from over 8 lakh liters to just 20,805 liters with an error range of 10%. Coming to the flood scenario itself, the structure will be able to sustain a maximum of 130 hours of going past the 60-hour requirement of the competition. In the next slide, here we depict the flow of water through our whole built as well as unbuilt areas, the different ways we collect water, the different places we use it, and how the recycling itself happens. This section here represents the integrated built level water cycle of the built structure designed to operate as a decentralized closed loop system to maximize efficient usage. Rainwater is collected through sloped surfaces directed via downpipes leading out of the, and also water leading out of gabion retaining walls into an underground rainwater storage tank. The water is then distributed through a pump system to meet non-potable demands such as flushing and irrigation. Grey water constitutes approximately 75% of daily wastewater and is segregated at source and directed to a two-stage treatment system, both anaerobic and aerobic filtration pits. Black water or wastewater is routed to septic tanks, and ultimately this cycle helps support a net zero water footprint at the building level while also demonstrating a replicable model for decentralized water management in climate vulnerable regions.
What you're looking at isn't just a foundation. It's a floating response to rising uncertainty. A foundation that doesn't assume that the flood will behave. It adapts to it, rising with changing levels, whether it's 0.5 meter or 4. Because in Assam, no two floods are ever the same, so our foundation couldn't be static either. It is built on 4 interlocking systems. Let's start from the underground. It starts with the micro piles that are drilled and grouted into the soil, above which the reinforced pile cap, the launch pad for what comes next. Fixed to the base is a hydraulic vertical guidance post, a recycled steel piston nestled in a casing. This post does 3 things. It pre-lifts the raft by 20 centimeters when a flood warning arrives. It guides the entire structure's vertical movement as the flood waters rise, ensuring 1.5 meters stay embedded, and the pistons absorb the seismic shocks during earthquakes. Our raft, a steel I-beam grid topped with poured plate, it is embedded with recycled HDPE pontoons, which are wrapped in recycled steel mesh to resist debris. It's a 2-meter deep trench filled not with concrete, but with gravel, geotextile, and gabions, because materials in Assam need to breathe with the flood, not crack under it. Let's talk numbers. Trench depth of 2 meter, buoyant force of 14.7 meganewton, structural load of 6.5 meganewton, for which we require 1,326 buoyant blocks, which is exactly enough to help us achieve neutral buoyancy. Here is an experimental demonstration. The trench slowly fills at 5 centimeter per minute. The building lifts gently in 20 minutes. It can remain afloat for 2 to 3 days or more, even in high water table conditions, which are common in Assam. Once surrounding floodwaters recede, the trench drains the water through the gravel and the geotextile, and then the building settles down, guided safely by our telescopic piston systems. No bounce, no tilt, no re-anchoring needed. Our structural analysis revealed a maximum lateral sway of 14 mm against the allowed limit of 16 mm. That's well within the limits, providing our steel frame is stiff enough to resist lateral displacement even under extreme loading. That means our structure lifts smoothly and floats calmly. That's the amphibious foundation. Simple, passive, resilient, and ready.
In terms of affordability, we have achieved a total hard cost of 5.1 crores and a total soft cost of 0.2 crores, adding up to a total of 5.3 crores. While civil works, internal works, and interest during construction take maximum proportions. Here, in the next slide, we compare a run-of-the-mill RCC structure to our bamboo and steel proposed structure, where we have seen considerable reductions in multiple aspects. As seen on the right in the table, we have also come up to the conclusion of a capex reduction of 25 to 35% and an opex per year of 7.1 lakhs. In the next slide, with a 40% subsidy from the Government of India, we have a cost of 3.1 crores, and from savings and revenue of 28 lakhs and 5 lakhs respectively, and a project lifetime of 20 plus years, we come to a payback period of 9.43 years, and after break even, we start seeing the structure paying for itself. Coming to surviving for more than 60 hours as given by SDI and the competition itself, we have split this into 4 aspects: water, medical supplies, food, and electricity. While we have listed down food and medical supplies, the necessities, water, we have 133 hours of survivability, and in terms of electricity, 72 plus hours.
Keeping resilience in mind, be it for earthquakes or floods, we have split the situation into 3 phases. Preparedness, considering risk mapping, community trailing, and connectivity resilience. Response, considering evacuation activation, emergency services, and communication. Recovery, considering damage assessment, mental health and well-being, and economic restart. This isn't just a shelter. It's a 20-plus year investment in resilience. Unlike traditional relief schools that fail within 5, ours is built to last. It prevents displacement, stabilizes livelihood, and better yet, it empowers the community itself. Locals are trained and employed to work in its construction. It functions not just as a school, but as a training center, a relief hub, and a long-time anchor for the village itself. Economically, it's smart. 20% cheaper to build, 50% less to maintain, and it saves more through solar, rainwater harvesting, and biodigesters. No rebuilds every 2 to 5 years, no wasted resources. With bamboo, recycled materials, and an amphibious foundation, this solution, it's not just sustainable, it's scalable. We're now seeking to connect with interested people and organizations to discuss the funding options to take this impact further, not just to build shelters, but to build futures.
Here are some of the government schemes that we've looked into that will help us in making our project a success. This is a small visual to give you a glimpse into how our structure would work in a real-life scenario. So that's the end of the presentation, and we would like to close it by saying, with water we rise. Thank you.
Very well finished in time, like you still have 2 minutes remaining. So great presentation. So we'll take comments from the jury or questions. Piyush, we'll start with you. You can use this.
Hello. Yeah, so I think lots of very interesting work. I really like aspects of the community engagement and the way you've tried to understand. Did you actually get a chance to visit site?
No, sir, we didn't get a chance to visit site, but we were able to get through to people who live there and have experienced it, so that we could get some personal insight.
Through our
Right.
project partners.
Right.
Yeah.
So, you know, I had, I guess, mainly 2 observations, and I'd also send this in our feedback last time. So one is on the architectural design and this whole cutout thing that you have in your floor. So the way I see it is that it really makes the space very public, right? Because voice, sound, activity, vision, and in some sense it compromises the space because you're looking at having people using that room to cross from one side to the other to access the ramp. And you also have light, ventilation, sound, vision that anybody can access from lower to upper floors. So how does this function if you're actually having a school running or when you have people actually living there? It's going to be a racket because you're going to have sound going up and down. There's no privacy. And in my comments, so in my observation, my question is, why do you need it? And it almost seems that it's been put in to ensure ventilation and light. So while ventilation and light are welcome, it really compromises the space in my view. That's one comment that I would like you all to respond on. And you know, while I see that you've put in more effort on explaining the amphibious foundation, I'm still a little unclear about this steel bamboo mix and the kind of details that the whole amphibious foundation demand from the design. And why would you have a building on stilts? Or rather, why not just have a building on stilts and take care of these problems during flooding than going through this what doesn't, it's not a bad idea, but it's the kind of floating foundations or amphibious foundations I've seen are in places that are almost perennially waterlogged. So here you're looking at a dry scenario, and hence you're creating a ditch where your wet scenario will sit, and in some sense you're inviting the water to come into that ditch and collect, and then as the water rises, your foundations are going to rise. So it's a bit like saying that we are going a little around the way to achieve conditions for an amphibious foundation. If your building was located, say, at the edge of a lake or was in a portion that was already had some level of water and it increased, there the amphibious foundation would have worked much better. So I think there are a few other comments, but these are my two main sort of comments, and I would like you all to respond to. Thanks.
Okay. Yeah. So first, we would like to address the concerns about the cutout. To be very honest, it was not just done for sunlighting and ventilation purposes. It was solely a design process where we realized that although the cutout is making that space public, the entire idea was that the shelter is a space for the public people of the village. Like, it's to create that community feeling. And once we pack the shelter without any cutout, it feels very congested and overcrowded, which is one of the main concerns which we got from one of our stakeholders. They said that it's too crammed up or it's too close by. They don't feel like there's any life inside the shelter. So we wanted to create a fun element. And also, for the circulation part, instead of creating corridors, we thought we'd create a cutout which naturally creates a corridor where people could move around. And also the training calendar makes sure that the functioning that is happening on each floor doesn't crash with the functioning of the other floor. Like, if there's a craft center on the 3rd floor, then there's also a craft center on the 2nd floor, which is not happening at the same time. So there's no disturbance happening on the 2nd floor. But in the same time, when there are families during crisis on different floors, they can look through, they can make it a lively environment instead of being packed in a box. And it did solve the ventilation and lighting issues as well. Coming to the main concern about the structure, I think they can answer better.
The foundation, the mix of steel and bamboo. Bamboo has come up because we are in the northeast of the country itself, and it's a very local material. It's very easy to source, and there are a lot of indigenous techniques which they themselves know better than any of us, and it's very easy to work with the people there. Steel has come up because of the foundation itself and how amphibious foundations work, and also because of a low carbon potential in steel itself compared to a traditional RCC structure. And coming to the why not stilts and have an amphibious foundation, there is this concept of economies of scale. We have tried to apply that in this, if this by chance gets taken up by a government initiative, because we are already working with an NGO. If an economies of scale thing comes into the picture, the amphibious foundation can be a really good idea to bring into the country, because India Even though there's a lot of cultures here, we do not have floating restaurants. We have restaurants and it's for the rich and not really for the poor. And we would like to boil that idea down for all economies as well. Yeah, I think we would like to add.
And also to add to that, through our research, we found out that stills they are a static exposed structure. So they are always, when the water does hit, the maintenance cost for stills is a lot more compared to our deflection analysis in an amphibious foundation. A still foundation will last for 50 to 70 years in a normal area, but in a flood-prone area, with the maintenance cost, it lasts up to 20 to 30 years, adding up to the cost. And an amphibious foundation, if it's maintained well, it needs to be, after a flood has hit, it only needs to be maintained once in 5 years, just checkups, which once we have a full recovery plan and this has taken, this has come into action, we'll have a proper plan as to how many maintenance we would require, but it's much lesser than stills.
Shaili, you want to ask one question that you have for the team? Sorry for interrupting you guys, because we are running really low on time.
Thank you.
You have to keep exchanging, is it? So guys, amazing storytelling. I think you guys are, you presented it in a very well coordinated way. So good going with that. One point that you had mentioned in your report specifically is you also mentioned here about interviewing the residents, right? And I guess it's a big number. I think it's 89 or something close to 90, which is a big number. I really wanted to understand, it's good to basically collect, what are the key pain points, what is their perspective, but how have you actually made use of that interview is something that I really wish you could have given a good connect between the two. There is one clear gap that I felt is there, so that is one comment from my side. One question that I had was basically with respect to the simulations that you had shown. So it's good to attempt and to do a quantified assessments of building in terms of what the numbers would look like. It's actually very, very important. But at the same time, I was wondering how have you calculated the CO2 concentration graph? So was it only based on simulation outputs, or how was that done?
Team, can you keep your answers short so that Isaac can also.
We have not plotted a CO2 concentration graph. Whatever results we have gotten from Design Builder for that, we have just put that up. We have not really plotted for embodied carbon in a graphical manner as such.
One thing that we did was implement all the materials that we've used in our structure into the, we fed that information into Design Builder.
Mm-hmm.
And once we ran the simulation, we, there's that tab simulation. So once we came upon that, we knew about CO2 levels. But other than that, there wasn't any other source that we used.
Okay, got it. No, because there is a plot that you have shown about, that's basically the CO2 concentration. It tells you how much ppm is there present in that room. So it's good to attempt it. My only point was that since your building is already open and very well ventilated, the factors that are affecting your CO2 concentrations might be different. So I was just curious to know, maybe that's a different, it's an in-depth topic we can discuss offline as well. Thank you.
Thank you.
Yeah, Isaac.
Okay.
Very quickly.
It's a beautiful presentation. I really appreciate it.
Sir.
And I also like the way that you changed that challenges in, from threats, you made it as challenges in the SWOC instead of SWOT. That's nice. I just have a couple of questions, and one is on the collaborative innovation. How sure are you on certain innovations, for example, the self-healing plaster or the waterproofing? You have not gone into a little in-depth part into these two aspects, as well as also the embodied carbon. You've done a great job, but transportation is almost nothing. But maybe, when you scale up, there's a lot of other things that you also take care of, right? So maybe just we can quickly comment on these two things.
Yes, sir.
Okay. Okay, talking about the ideas of having self-healing materials and water treatment aspects as such, we did talk to a few industry partners themselves, and we did not go for bitumen waterproofing as such. So, and also we did try to look into a few scientific advancements and how they could help in a local rural area. But costs kept getting too high every time we looked into those scientific advancements. And talking about transport,
So the question was, I mean, are they really in practice or they're just research?
Regarding waterproofing, I can talk. The one thing that we've used is bamboo mat corrugated sheets. One of the things that we did was, instead of using galvanized iron sheets and bitumen and the normal things that we use, instead of that we tried sticking to the local context, and then we found that this sheet would work better because we went according to the Bureau of Indian Standards IS codes, and then we found that this structure, that component could be used for waterproofing in our structure. So we did a thorough study of it. We ran through the technical aspects, and then we came upon that part.
coming to the transport part, all of the materials are sourced from the nearest major city, was Jorhat. And because Assam is relatively a more rural state in the country, we wouldn't like to source it from anywhere else in India and make them travel to a corner of the country itself.
So just to come back to your self-healing plaster, I think we were also a little bit confused while going through the comments because we weren't aware that it was mentioned anywhere. We discovered once we saw the reviews. I don't think we have proposed a self-healing plaster for the structure. If there is, we are not aware of it.
I'll show it to you later.
Yeah.
Yeah, if by mistake maybe. But
Yeah.
currently it's not there in the project. And so just to add to your still part.
Team, I'm sorry. We are actually,
Okay.
going.
Okay, thank
Yeah,
you.
thank you. So for our second presentation, we have Team Bhumika, and they have worked on Project Stita in Wayanad, Kerala. So team, same instructions as before. You'll have 20 minutes to present your work to the jury. At 15 minutes, I'll ring a bell like this, and you won't have a 21st minute. I'll have to stop you at the 20th minute. After that, we'll have a 10-minute Q&A with the jury, and keep your answers direct and to the point. So team, the stage is yours. All the best. Can you go into slideshow mode? Okay. Yeah. Yes, please start.
Okay. It was just another night in Churulmala. The skies opened up, as they often do in Kerala. The rain started pouring down into the village. It was a very familiar sound to them. They used to sleep at night listening to this sound. They felt it was very normal to them. But in one night, when they woke up the next day, a few couldn't. A very fortunate few could. What came that night was a disaster, which though through a lot of homes, shattered a lot of lives, left a scar on the heart of the community. In moments like these, when nature strikes without a warning, we are reminded of the painful truth. Resilience cannot wait until after the storm. The need for resilience is shelter is not a luxury, it's a lifeline. With the right systems in place, we can save more lives than we ever thought was possible. Good morning, everyone, respected jury members. We are Team Bhumika from College of Engineering Trivandrum. Today we present to you our project, Stida, a space where hope finds shelter, and shelter means more than just survival. Moving on, this is just to give a context about the project overview. Our site is in Wayanad. It's a place with lush hills and a beautiful scenery everywhere. But it's also a place where repeated tragedy has happened. In 2019, Pudumala, and in 2024, Churulmala, the landslides triggered by monsoons, worsened by deforestation, have left scars not just on the earth, but on lives. Homes were swept away, incomes were lost, and relief were delayed. When in this situation, we ask questions like, can shelter mean more? Can it prepare and just not repair? We chose a site called Mepadi. This site was actually surrounded around these deeply affected around these deeply affected things. In this, you can see our site is proposed around the places where the landslide was hit, and it was and this site had good conditions when it comes to the wind, and it could be a good lifeline for such resident shelter should be placed. And this site had a solar exposure of around 1106 kilowatt per meter square, which could give us an opportunity for good energy self-reliance. And our design and our approach is actually oriented towards nature and not to destroy it. And coming on to the design.
So moving to the concept, we designed our project by integrating Kerala architecture style and with respect to the climate and the layers we taken from the site analysis. And we major turning point our design develop is to we identified the drainage pattern in our site from majorly with the major three drainage pattern we founded and 3 rainwater harvesting pit we have designed. This is the major turning point of our design. With these strategies, we have a major road in the west side of the site. So it's also we have to, according to the bylaws, we have to give 12 meters of yard space in front. So how we can use this space for the development of this. We use immediate parking spaces near to the major road network, and we also below the parking we have provided rainwater harvesting tank. So it's the major lower level of the site itself. So this is the basic conceptual illustration of our project. We provided parking spaces in front of the road, then given a Kerala Padipura. It's a welcoming space in Kerala architecture style, Kerala architecture. We use a Padipura in our design. In here, the space. It's also act as a community plaza in our design. Also, we provided Gen Seva Kendra, which is used as a community service space. Also, we used Gen Aushadhi Kendra for the better health and well-being of the people in Maypadi. Then we integrated, according to the basic design principle, we use balance, symmetry, balance, and a focus point created through the Padipura spaces in our design. This is the major focus point we created, and the major focus will come at the major block. So in the major block itself, we develop a kinetic facade system. It's a traditional rooted material from the site itself. This material is used in the community peoples for their fences making and gate construction. So this is the major focus point over here. We place one building over one side and another building in right side. So this is the storerooms, and this is the major plaza in our design, and the major block. Come to next. So it's coming to the master plan. We zoned our spaces according to the site analysis layers. We provide a kitchen and dining area for the volunteers and the people user group, major user group of the design bus volunteers, and the people come before the disaster and after the disaster in the time of resilience. So we provided a kitchen and dining space in front line and multipurpose hall and accommodation space in the back side of the set. So this is the major, when come to the line, this one is the store, which is a Gen Seva Kendra, and which is also used as ration shop for community supply services. And the second space is the admin of the total project. And third is the Gen Seva Kendra, which is used as a community service oriented project. And fourth is the Gen Aushadhi Kendra, which is also a clinic for the community peoples. And five, it's Kudumbasri Janagiya Hotel, which is act as a restaurant at the non-resilience time, and the time of resilience it acts as a community kitchen. So it is actively used by the common peoples in Maypadi. So the sixth one is the community hall, which is used as a skill development center. Also, in the time of resilience, it is the major meetings and all the press meets will be conducted. And seven will be the dormitory spaces, which has been provided for the accommodation of the resilient people. And eight, which is a rainwater harvesting tank, which is a major focus point in our design. And the nine is the kids play area. And 10 is the major parking space, which is we also provided electrical EV charging stations for as a sustainable measure for the vehicular transport system. So this is the first floor plan of our design. We can provide a all welcoming entry, and this is the major entry focus point. Here we go with the Padipura spaces, and this is the major community plaza or space which can be accommodated. We can use as a gallery spaces where people can sit. So we can develop community interaction spaces in between the students and the kids and the people can use that space. And this is the restaurant place. And moving to the clinic area, and we go take it as a universal design strategy. We use RAM system for go to clinic, and we can use this RAM also for the access community hall. We also provided a lift service for accommodation spaces in above the major dormitory space. So we integrated solar panel facing south side, solar panel facing south side, and curtain blinds and facades gives a traditional feel in Wayanad itself. Also, we given the Padipura as a kids play area around catchment. Also, we provided EV charging commercial outlet space for selling agri products and community made products, fishes, etc. in these places. Next slide. So this is the major view of our restaurant and community hall and dormitory spaces and rail integrated modular furniture, which is act as a this is the major rail integrated modular function. We can, in the time of resilience, we can place food, and the people are volunteers are working very rashly in that time. So people can take breakfast or lunch at the time of resilience, and they can use this space, and at the time of they can rest, we can use this modular integrated system as a chair. Also we can sit in this space, and we can use this This is the collaborative innovation technique. Also, so when coming to this community hall, which can be converted into classroom, workspaces, meeting rooms, and even dormitory during emergency situations. Outdoor gathering space around water catchment pit with aqua plants and fish cultivation, which will also generate economy for the community. So this is the overall view of our design. This is the major Padipura space, which is a bamboo integrated space, and this is the restaurant space and health unit. So moving to the resilience.
Moving to the resilience part. So first of all, what we found the potential risks of the site. So by the hydrology, the site experiences heavy rainfall, and for the climate and orientation, the site is actually oriented in the western side, and it's and for the structural and geotechnical and ecology and environment, the site is a contour site. So what we bring is for the topography responsive design, we brought bioengineering technique in which dense, deep-rooted vegetation is provided in the topsoil to hold, and we also introduced a debris retaining wall. Then we introduced well-treated arecanite palm screens, which hinders the western harsh solar radiation, and also it allows air movement into the indoor space, which enhances the thermal comfort. So this is the functional aspect of the space. So we provided a multi-purpose hall. So during disaster, this works as a dormitory space, and during the normal time, it works as a assembly hall, and also by using the partition walls, we could classes can be conducted inside this multi-purpose halls. And there is also a Padipura structure, so that's a focal point in our design. So it acts as an assembly point during the disaster, and the normal time it works as a recreational space. So these are the charts and graphs which we analyze the climatic condition, and through multiple iterations of the simulations, for the illumination we could get minimum of 110 lux, and for the wind and air movement analysis we were able to achieve 0.25 meter per second ventilation rate. So through these iterations, we were able to conclude a design with enhanced efficiency and maximum thermal comfort. And for health and well-being, we have provided a roofing that's a vaulted roof with solar panels, which reduces the direct solar heat gain. And we provided internal courtyards to improve the daylighting, and also ensuring the privacy of the space. And we also provided a children's play area, which provide a safe and engaging space for the kids. And also the arecanite tree facade, it provides natural lighting, ventilation, but it also adds aesthetic appeal to the old structure. And accessibility, it's universally it is inclusive to all community, and community gathering spaces were provided to foster the connection between the communities. And also we provided flame tree as main vegetation, because it has a dense canopy which provides shading and also purifies the air. So this is the water performance and the water balance chart. From this, we were able to achieve 55% of reduction in water use consumption, and also 90% of the harvested rainwater were able to meet all the water needs. And also 85 liters per capita is maintained in daily basis for both normal and emergency scenarios. So this is the water cycle. So in this, there is a there is stormwater is collected through recharge pits, and it's filtered and moved to the groundwater. Then the rainwater from the rooftops is collected in the underground tank, and the potable waters used by the water fixtures, and the grey water from this is treated and utilized for the flushing, and the black water from the toilets is treated and it's used for irrigation, and also the sludge collected from this treatment plants is used as a manure. And for this water efficiency, we were able to achieve by using low flow fixtures and aerated taps, and also that's it.
So moving to the innovation part, we use adequate palm-based facade system, which is a traditional material which is used by the community of Maypadi for constructing fences and all those things. Why we choose this material is to make sense of owner for the project to the community, and this is the overall design of the facade, and it's like a horizontal panel system which can be used as a kinetic facade system by using solar heat sensing motors installation, and it is the overall structure of constructing overall the facade system. So it's act like a horizontal lever system for when the heat gains, it will automatically adjust according to the solar orientation on all those things. And coming to the bamboo pavilion rainwater collection thing, it is the major padipura or major design element in our design. In the underground space, which is used as a kids play area, and the top of most the pavilion roof collect the rainwater and provide it into the rainwater harvesting tank. And moving to the major engineering and operation, we use CSCB wall cross section. This is the overall CSCB wall cross section. We use the PCC foundation and random bubble PCC and random bubble foundation, and we use compressed stabilized earth block, which is also an innovation which is mixed with the aragonite fibers. So when come to the waste management train, we use compost pipe in between 2 meters in overall site. We use as a it will also generate fertilizing for the landscape we have provided. So this is the major construction techniques and made. We use CSCB blocks and aragonite palm wood, and also for flooring we use stone flooring, and stabilized rammed earth for walls, and then rammed rubble trench. For also use joinery for coconut. This is also a modular furniture system we can use as a bed space, bunk bed in the resilience time, and we can use as a partition wall in the time of community workshop happening, and we also use as a seat in the time of non-resilience time.
Now let's focus on the carbon footprint and material impact. There is a reduction in carbon emission from 4,053.7 kg carbon dioxide to 1,189.7 kg carbon dioxide, and this reduction is achieved through agroforestry, bamboo planting, and regenerative farming. Then talking about the affordability, the net cost for the estimated project was 44.4 million rupees, and for the proposed design it was 40.6 million rupees. This reduction was is through using the skilled labours and the locally available materials. Then about energy performance, on-site renewable solar energy generated more than 1 lakh kilowatt hour per year, and the panels we used is 192 for an area for 400 meters square. And some energy reduction strategies we implemented was use of BLDC fans, LED lamps, lex level and occupancy sensor lights, vaulted roofing, and arcanite facade, also CACB and rammed earth. Now, energy performance. We calculated the total energy consumption for baseline and the proposed system. Then there is the EPI of baseline scenario was 74.39 kilowatt hour per square meter, and the EPI of proposed case is 49.08 kilowatt hour per square meter. And this reduction is achieved by, that's a 41% reduction. And this is achieved by LED lamps and using BLDC fans, etc. I already mentioned about that.
Coming on to what is the value that we get from this project is, so our project SDI is aligned with national goals such as renewable energy, rural employment, and inclusive development, as we have already told. And we provide such facilities over here, and it hosts around EV size stations, health clinics, fitness zones, community market, and in disaster it shelters and in peace it thrives.
Thank you, team. That was, sorry, your time is up. So we'll take comments from the jury. Isaac, we'll start with you this time.
Okay, so don't worry about the time, it's done. Now let's focus on the Q&A. So, well done. I think you've done a great job, and hats off to you. I like especially what did you say that word was, the central piece around which the entire, Padipura. So the Padipura around which the whole thing develops. So that's so you've done a very good job of maintaining the traditional aspects along with it.
Yes, sir.
And at the same time, you have accelerated and fast forwarded to very high levels of sophistication. That's what I get the feeling is. And it's a very simple question I have. Do you think you need a very dedicated team for the maintenance of this? Or how is it going to be easy? You have sensors, you have lot of things which need a little bit of dedicated.
Yeah,
so just a quick answer if you can give.
Sir, the restaurant was functioned by the Kudumbasri people. It is also a government funded project in Kerala, and they will every time we can purchase one meal for 20 rupees in Kerala. So it's a very community initiated project by the Kerala government. Also by the Jan Aushadhi Kendra. It's also a government project. There is the clinic and the pharmacist will be also from the government servants also. And for we use mostly a community-based project. So we can develop community interaction spaces. So the sense of how in our design we develop a sense of honoring. So the people can use that space and then they can maintain.
Okay, that's fine.
Space.
The maintenance aspects, the physical maintenance aspects of the engineering and operations, etc.
Okay.
So it can be easily done by the local people themselves, the villagers.
Yeah.
Yeah.
So also the major admin was be a provider for that. There will be a small team for all those service and for the lift and all those things.
So, team, firstly, I really like the render that you have shown. I think quite an effort that you guys have put in, so great job with it. And as Isaac mentioned, what I really liked about your design is you have tried to balance both the modern elements as well as the traditional elements. So that's also one thing which is commendable. I had a question with respect to the shoebox model that you had shown for thermal analysis. I think you have tried to check the radiation which is falling because of different orientations, right?
Yes.
So how have you translated that assessment into this design?
So when it comes to that, we have tried different orientations, and we have tried to orientate in all the directions possible, and try to see what's the best solution.
Mm-hmm.
We have come to know that whatever orientation we put it in, the difference between each and every orientation, especially for this each site, is almost negligible. So we try to orient the whole design according to the contour and try to minimize the land cutting and the land filling within the area itself. So we try to prioritize on the making the design more oriented towards the contour rather than focusing on the orientation according to the solar thing. Although we try to maximize on that too when it comes to other factors.
Mm-hmm. No, but it would have been great if this was also integrated in your report.
Yeah.
And also you mentioned about iterating your building design to achieve the adequate daylight levels. right? So that also, if you could have actually explained here that what kind of changes did you do to reach at this design stage, keeping in mind the comfort of the occupants. Okay, thank you.
Thank you, Shaili. Piyush.
Yeah, so I think couple of questions here. So one is that I find this use of bamboo shingles for roofing a bit questionable, honestly, because we're looking at very high rainfall areas. We're looking at shelter, which is going to be used during an event. So how do you justify it? It looks great, maybe for a tourist place with a lot of maintenance. That's one comment, and I would like to respond to. And the second is that I find both impressive and challenging the fact that you've used different build forms and different constructive systems. So you're making your work complex because you have one building which is in rammed earth, other buildings are CSEB, somewhere you're using some other kind of material. Your roofing systems are ferrocrete walls, your roofing systems are bamboo shingles. So that is something which I think has a charm in terms of, but it also has some challenges. So if you can comment on both these things.
Okay, so when it comes to the bamboo shingles, we tried to use that for certain areas, especially the front buildings, which has like quite a small this thing. So just to show, it's like a different alternative material rather than something called like a mangrove roof tile. And this bamboo shingles, it's made from a locally available material. Bamboo is really available in Wayanad. So using that bamboo and making it very well treated, it actually does stay for quite a long time. And we have used such different type of customer systems in different building. We try to not really make it according to make it like quite simple. So in terms of the space, what the dormitory needs, we went, okay, for this dormitory we need a system like this. For the multipurpose hall we need a ferrocement ceiling so that most of the daylighting comes inside and most of the people are when they use it, it's quite well lit. And when it comes to dormitory, we use such a system so that it caters to that. So we went according to such way of designing, not play according to what's less complex. We went according to what our design needs.
Do we have some more time?
Yeah, we have about 3 minutes.
Okay, so maybe I have one remark and then. So when you look at ferrocrete vaulted roofing, there are two challenges. One is the heat gain because it's a very thin material. And second is that in very high rainfall areas like Kerala, there's a good chance that it's going to leak. If you study ferrocrete roofing, these are the typical challenges that people face, which is why it's not being used extensively for roofing. That's one. And second is, there is of course a local material focus, which is great. But bamboo shingles, I don't know, it's still for me, it doesn't seem that it's going to be very sustainable. You'll have to keep replacing it, it'll get damaged. Anyway, so.
We have 2 minutes. If any more comments or questions.
Okay, maybe I want to go a little bit beyond. You mentioned 4 factors in your resilience aspect. Is that all, or do you think I'm just going a little beyond it? What about anthropology, or what about the people behavior?
I mean, these are like the main focuses we have done, and according to the challenges which we have placed, we have faced in the site itself when we visited.
You visited the site?
Yeah,
oh?
We have.
Okay.
We have gone in person and visited it. So when we went to that, I felt
what are the changes which took place?
The other factors are not necessary. We have looked into it, but these are the major 4 factors which we have to point out to you guys to explain our design.
Okay.
That's what.
So there's lots of changes which are happening around that area, which are actually causing these disasters.
Yeah. Okay, so as you could have seen in that map itself, around our site is in the safe zone of the landslide happening place itself, and it's it's okay over here. Our proposed site is over there, and already in this place there is a little bit behind. There is already a housing system for the people who have already affected from this previously happened landslide. So this space is actually a very safe space for the people to come and find resilience during the time of disaster.
Okay.
Okay, thank you. Thank you, jury members. Thank you, team, for your presentation. So now we'll take a 15-minute tea break, and we'll be back by 11:20. And third team, I'm requesting you to be ready.
The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through, The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, rolling so high, high, high. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so high, high, high. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world's so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through.
So welcome back everybody after the short break. Now we'll go on to the next team for their presentation. So the next team is Team Marutam, and they have worked on a community resilience shelter in Wayanad, Kerala. So team, take the stage, and can you open your presentations? Okay, yes. So team, you'll have 20 minutes for presenting your work. At 15 minutes, I'll ring a bell like this. You won't have a 21st minute, and I'll need to ask you to stop at the 20th minute. After that, we'll do a 10-minute Q&A with our jury members, and so keep your answers direct and to the point. So, okay, team, the stage is yours. You're ready to start? Yeah. Okay, all the best.
Okay, so good morning, everybody. A very warm morning. First of all, let me express my sincere gratitude for SDI for giving us such a good opportunity to share our thoughts. We express our gratitude to our project partner, industrial partners, Good Earth Initiatives, and Taurus. So, okay, so let me begin with our presentation. So basically, I'll just give you a scenario. First, what do you do if a rain, which is supposed to pour taking a month, start to pour within a day? So the problem in Wayanad is actually rain. And we have tried our best to resolve it. And during a disaster, the 3 effective R's, which we already know, response, readiness, and recovery, works better. Anybody would try their best to approach a structure which is easily approachable, simple as the way it is. So we have tried our best to make our structure very simple, and we have integrated community. We have better analyzed the site. We visited it 3 times. We understood that community there composes of daily wage workers, plumbers, painters, and so we are working for such communities. So this is a brief idea I'm giving, and the problem, the rain, which is a major concern. So now let's move to the first slide. So this is our design planning, where basically our plot area is 4,000, and we have 2 units. We have tried our best to make the structure into a triangular form. As I mentioned, the first issue is the rain, second, the sun, and third, the management by which it is to be continued by the community. We don't want them to rely upon external, but the community to carry out the structure further. So basically our design has 2 units, which is splitted by a central courtyard. And in the next slide, we can see this is a section where you can see actually our structure is 3 units. The bottom part is a flexible space which can be used as market or the interactive area. The next part, that's the main ground floor, is the community area. It is where we shelter the habitats like people during the time of disaster. The upper part is our like putting forward a new strategy of hydroponics, which is already there, but we think it has to be efficient here also. And we'll explain it why we are introducing this to the community. And you see there is a market space, central space, 7 into 27 in general. And we see the spaces can be partitioned, but we are not restricting it in any way that it has to be flexible during that time. We know a lot of operations happen during a time of disaster. So it has to be flexible enough. It should avoid confusion and it should be inclusive as possible. So we haven't made any confusion for the people that it's all direct. The upper part where the slope, the structure is following the slope. So automatically we have provisions in our site to take people to the bottom part so that they can assess the structure directly from behind and also from front. We also have lift provision and we have considered the factor of 80 to 90% of people there are disabled during a disaster. So the consideration and focus is definitely for that people than the normal people. And in this is a planning. And inclusiveness is a main element we have incorporated, as I've said. And our structure offers dual purpose, which we'll be explaining in the further slides. I'll be passing for the engineering and operation.
So coming into engineering and operations, we have a few components in the structure that I'll be explaining. So the main structure, A-frame, the main structure is the A-frame steel structure. So which is made of steel beams, which is connected to a rigid frame. It has horizontal cross beams for additional support. And the joints are bolted, which is flexible for dismantling and relocating. The second component is bamboo shingles that is used for roofing. These are thin pieces of woven bamboo, and they are eco-friendly and a sustainable alternative. And we have also bamboo wall partitions, which is an excellent which is excellent for ventilation, and it is easy for installation, and it has minimal maintenance. Then the next component is the raft foundation. In the site we have a high expansive clayey soil which is soft. So we've used raft foundation to spread the load evenly across the ground. And coming into the water operation system, at every 5-meter interval we have provided inspection chambers and manhole shafts. There's a septic tank, then there is a biodigester, and there is a overhead water tank. Then coming into the biodigester, we've used Deen Bandhu biogas plant, which is a dome-shaped plant, which is made of ferro cement or concrete. So this Deen Bandhu is coming under the government scheme of National Biogas and Manure Management Program. So this is the basics of engineering and operations.
Next, we'll move on to the innovation. The first is our earthlock RH blocks, which we are actually taking the we are excavating the site. So we are taking 650 meter cube of soil, from which the possible amount of CSEB brick which we can make is 1,05,000. But we are making 16,280 blocks from the site soil itself, compressing it manually, such that we are making use of the community. As I've mentioned, the community pattern is mentioned there, the agricultural laborers, daily wages, construction workers. So we are better educating them in a better way possible, where experimenting with bamboo, we could find there when we visited the place thoroughly. We see people are ready to accept, they are ready to move forward with such technologies. So we thought, why can't we make use of that opportunity? So we took earthlock RH blocks, which does not require mortar. So actually we are conserving huge amount of mortar also here. And then the next is tri-mode A-frame. It is our structure by itself. It's actually a steel A-frame, which is actually showing a very good possibility of dismantling also. Even if you want to show the repetition of this unit elsewhere, you can actually, the joints here is bolted. You can easily dismantle it easily and assemble it easily. And you can see the section, we have made use of the climate analysis. as I've mentioned, the rain is the first thing we have to tackle about. So we are giving the shade of that much already, which is already excessive. And the rain which falls directly there, we are giving pavers mixed with greens and the tiles. So we are actually, after that area, we are giving bamboo flooring. And that is extended corridor, like a connection with the exterior. We are taking excellent use of the natural winds, which is there in a very good way in Wayanad. And there we are making use of the rain also there, a partial outdoor space. And then we see multi-flexible spatial pattern of our structure. And that's a wind direction. You can see how we have managed the wind in and out of the structure. Okay. And next, our unit is Shelth Right, which is our component model. We are showing a possibility of how we can dismantle something. It has to be that flexible enough during a time of disaster. And there are chances during a disaster for pandemic spread. So there need isolation units. And we need to give consideration of our women and children and communities at that time, which has to be segregated. So in that aspect, we are giving provision for that flexibility also, which has to be addressed. And we have made our spaces as flexible as we can so that people can directly, and actually we had some limitations with the material, so we went with the blue at the last time. It's actually a transparent material which can create pattern also, aesthetic pattern like, and we are welcoming people into the structure during that time. And design for emphasis. We are making the entrance bright colored so that people at that time who are under panic will automatically feel to approach the building as fast as they can. And that's a solar glide, which is a common thing which we see, but why can't we experiment it with solar? Like the smaller provisions, but we can make use of the renewable energies. And that we also shown a solar glide, which is a climate responsive concept of sunflower. It take the full efficiency of the sun in all the way possible, but we are putting it as an option where affordability is a concern in India. As we followed the Indian Green Building Council, we see affordability, social integration, and cultural significance. It's all important. So in that scenario, we are just keeping that as an option that we can put if required. And next is health and well-being. We understood the climate analysis, the same as I mentioned, rain, sun, and the service. And we have incorporated many native and exotic plants in our design. And that's an inference from the psychometric chart. And as per Indian Green Building Council, the daylighting is addressing that 110 lux must be ensured in the common areas, which definitely is achieved. And in the toilets, which is not even mentioned in the IGBC, we are compromising there only. But still, it's following 122, which is also crossing the necessary mandatory requirement. And then we have performed the window and CFD analysis. We came to assure that we are ensuring the cross ventilation in all the way possible. And this is a bamboo roof, which we've already discussed.
Okay, next is the energy performance. So in order to minimize the environmental impact, we have adopted two strategies. One is to generate on-site power, which is more than the required number. So we are actually achieving a net positive performance and also minimizing the energy consumption by increasing the efficiency of the products that we use. So we are implementing smart energy system that further increases the efficiency of the overall efficiency and overall performance of the design. And this is the comparison between the baseline scenario and the proposed scenario, where during the disaster timing, and the baseline scenario, the proposed scenario outshines the baseline scenario in case of the energy efficiency, as the proposed scenario only consumes about 82,000 kilowatt per year, whereas the baseline consumes around 1,20,000. And here also a similar comparison during the non-disaster on-grid time. Here, like the previous cases, the proposed scenario is has more energy efficient than the baseline scenario, and A-frame structure that mentioned above implementing the A-frame structure, the heat gain is reduced by 20 to 35% due to its solar radiation reflectant property, thereby reducing the indoor temperature up to 3.5 to 5 degree where compared to the traditional counterparts. And this also led to a decreasing in the cooling energy requirements up to 40%. And the other energy efficiency and heat reducing strategy we used are tri-mode A-frame design, passive cooling, high temperature insulation, strategical shading, etc. And when it comes to scheduling of equipments, this also plays a huge role in the energy performance by just allocating the necessary energy that is needed to execute an activity without compromising in its performance. And this can be done by using very low energy demanding motion sensors and all. And coming to water performance, as we all know, water is an important element to sustain our life. So water performance also demands the same attention. Here we have resorted to rainwater harvesting, water recycling, reusing, and stormwater management, ultra-low fixtures, and smart meters to improve our water performance. Effective smart meters. Smart meters are one of the important things in the water performance design, and the smart meters help to improve the accuracy of the building, locate early detection leaks, and also it increases the water conservation, thereby imposing less load on the nature. And also the ultra-low fixtures performs the same activity while demanding less water use. Next is the external service layout, where the rainwater, runoff water, and the grey water black water produce, each are taken care of separately, and almost completely the grey water has been reused for the landscape maintenance of landscaping, flushing, etc. And when it comes to embodied carbon, our design reduces the carbon footprint of the construction material, a whopping of 77.3% reduction in the overall carbon, embodied carbon, and decreasing carbon equivalent emission. We had done this through steel trusses, bamboo columns, solar panels, bamboo partitions, etc. And when it comes to the comparison between normal traditional components and the bamboo, we have replaced the cement blocks, roofing, etc. And when it comes to bamboo shingles, the waterproofing and the by properly treated bamboo shingles can and regular maintenance can actually be a sustainable way to replace the concrete slabs. And careful design of the design and choosing of the selection of plants for the green roofing can also increase in the drainage.
So coming into resilience, what we have incorporated in the design is that we've done a retaining wall to hold back soil. We've used bamboo construction to provide strong and earthquake resistant buildings. Then we have a steel frame which is durable, fire resistant, and structural, gives structural strength in the buildings. There's vertical garden to reduce heat and improves air quality. During the non-disaster and disaster time, the structure converts. We have hydroponics in the roof, which is a feature that runs throughout the year. Then we have, during the disaster time, there is a community hall with dining halls in the balconies, and that during the non-disaster time will be converted into workshop area and food courts. Then we have, during the disaster time, there are storage areas, and during non-disaster time, that space gets converted into shops. And also during the non-disaster time, we have spaces like workshop areas, solar power area, then open markets and animal shelters provided in the site.
Coming to affordability, there is a detailed comparison between the two baseline and the proposed scenario. And as per the meter square pricing, for the proposed scenario, the cost reduction is due to the earthlock RH blocks being used and the tri-mod A-frames, along with the efficient MP services, and also the repurposing of existing RCC structure on the sites. And the the reduction in the total value is due to careful resizing of the actual design, rescaling of the actual design, and also without compromising in the consultation fees, design and planning efforts extra, and significant reduction in the contingency costs also implies better predictability. And this is a total comparison between the two scenarios, where the proposed scenario is 9 million, saves us 9 million rupee. And the outsourcing of local material and all are as mentioned earlier.
So coming into the value proposition, this project cuts cost up to 50% using local materials and passive design. It saves up to 25 to 35% with prefab methods and boosts energy efficiency with solar, biogas and insulation. The project supports resource use, water harvesting, and offers a strong ROI through hydroponics. Then this project empowers rural communities through multi-purpose shelters that support disaster relief, skill training, and social activities. It promotes market activities with eco-friendly biogas powered setups for local trade and farming. It aligns with key government schemes like PM Kusum, PM DKY, KCC, and the National Mission on High Yield Seeds. Schemes like PM KSY and RKVY to boost water use efficiency and innovation, while NHM and biogas development of 2023 enhance nutrition livelihoods and energy self-reliance.
These are some renders of ours which we would like to share with you. And the component model, we are assuring like all the parts in that can be dismantled. So we can actually fold it, compact it, and put into the storage, and whenever it's required, we can put it out and unfold it. Thank you.
Thank you, team. That was a great presentation. Shaili, you want to go first?
So what I really liked about your design was the concept of inclusivity. I think that's something that you guys have emphasized a lot in your report as well. So good job with that. Even Shelterite is another concept that which the prototype for which is over here. So I wanted to understand it in a little better way, that this will be only used during the crisis time, right?
Yes, ma'am.
So what kind of benefits would it bring?
Ma'am, actually, during a disaster, the need is different. Actually, in case if there a pandemic comes, and in case of a family to be isolated, like women, children, or disabled, or old people, there is a need to give provision for them separately. That's what we have introduced this. Such units which act as emergency units during that time. It will not be displayed during other time. It will be put inside the storage only. And whenever the need comes, we'll put it out and assemble. So we are just putting forward a fact that there should be emergency provisions given in a design, especially when in case of immediate response is needed in a disaster time.
Okay. And the other point was you showcased a lot of your work around daylighting simulations and all. But I'm not very clear how have you defined your base case to begin with, because it's good to show that you are able to improvise significantly.
in terms of your base case versus what you are proposing. But at the same time, it's very important to mention what have you considered in the base case at the first place, because it's very easy to consider it to be, quite worse in terms of architectural design or features. So in order to have a good comparison, it's also important to mention it very clearly, even in the report and even in the presentation. So would you want to talk a little bit about that?
Actually, we have tried to exhibit the design in detail in all the way possible, and as a part of that, we were actually made to reduce certain baseline and just give the analysis out of it. So it turned out to be like baseline was not clear. So
that's something that is very, very important, right? Because if you have to compare and quantify how your design is better than a conventional system or a baseline building, so for that, it's very, very important to first define that.
Yes,
It could not be very simple, I understand, but there need to be a clear case so that it helps you to quantify the numbers. And also, one more question was on the A-line design that you have proposed. So multiple instances, even in your presentation, you mentioned that it helps with energy savings or providing thermal comfort, or it also helps in deflecting the wind. So can you actually explain how would that happen?
Ma'am, actually, you can see that we are not actually deflecting the wind. We are actually making the wind in all the way possible. And then we are making a climate response. Like when rain is an issue, we definitely need a slope there. And then the material on a global level, it has to be climate responsive. So as a part of it, we have introduced the green roof. We have got a comment that green roof works. But when we look in general, green roof also helps in heat reduction. And then it can act as a good solution also for a good green facade. And then we went for bamboo shingle. Actually, in parts like Assam, Meghalaya, Bali, Vietnam and all, we know definitely they have experimented to a great extent with bamboo. So if we make sure that it's treated very well, and if we make sure that the service and maintenance of this is taken care, which we are sure that the community there are willing enough, like we have said now, the community pattern. So they were ready to experiment. And we know the women here are majorly homemakers. So and they have a special interest over horticulture is what we felt when we visited, and they have a special attachment also to greens. So we are displacing this much greens there, and we think it's a social responsibility also as architects to displace it back in any way possible. So we encourage hydroponics. So people can manage it actually. Once we can teach them, we can educate the community, they can carry out in a very effective way where they can cultivate the exotic crops also very effectively.
That's it. Thank you.
Thank you, Shaili. Piyush.
Yeah, so see, your whole design premise is based on this A-frame, and then you're trying to work things around it. But if you look at the section, and if I look at the needs of a space, especially during disaster, what you need to ensure community is that there is secure space.
Yes.
And what does secure space mean? It means that it doesn't get wet in the rain. If it's a high wind speed event, if there is a landslide event, that area is secure. Right? Now, what is happening in this design, in my view, is that you're getting very little secured space. What you're getting is large open spaces, semi-open spaces. Now, just look at what happens here if there's a heavy rainfall event. Your verandas are going to be completely wet.
Sir, actually, can you take the before slide? Sir, we are giving an extended space actually. We are already giving we are giving 2.5 already as a corridor. We are giving extended 2 meter again, and that we are making it, let them use it if they want it in a partial rain feeling also, like our outdoor space. So we are extending it actually. We are already shading the corridors.
Yeah, anyway, let's not revisit the design. The way your section is, you only have that space which is secure. Everything else is subject to getting wet in the rain, is what I'm trying to say.
Yes, sir.
And that space cannot really be put to use. So, for example, the spaces that you're showing as even covered on the, I don't know how to describe it, the first floor. Yeah, so the blue parts are getting wet in the rain, and that rain is going to go in right up to the walls. That's what I'm trying to say.
Sir, in the terms of walls, we have actually taken the degree from where accurately this base point can be shaded from the rains and from the sun. And then we have
Yeah,
given
but rainwater flows, you know, is going to completely wet your open spaces. Anyway,
okay, sir.
so I think that's my main comment, is that in using the A-frame, there are some positives, but there are some negatives.
Yes, sir.
And I think that here, it seems like some of these negatives have probably not been thought through adequately for a disaster scenario. I'll pass it on to Isaac.
Okay, well done. And especially I liked your statement about how you said 1 month rain falling in one day. So that factor has been really taken into it, because I think every year there is an increase in the intensity. Okay, so you're confident about hydroponics?
Sir, actually, it was a utopian concept, and then people say it was an alien concept. But you can see in Mumbai, in many places, within a small space, they are practicing it. And even in the same Wayanad, where we think hydroponics will be a challenging thing, I don't remember his name, but there is an entrepreneur recently, a youngster. He has cultivated saffron to a great quantity. He's also doing it in Wayanad only. So actually people in Wayanad is actually practicing, and what if we can give a furthermore support to encourage it?
Oh yeah, no, because it's not easy. It requires a lot of training. That's important. One question I had was, okay, the cool roof, what do you mean actually is the green roof?
Cool roof.
Yeah, you had mentioned cool roof.
It's green roof, sir.
It's green roof.
Yes, sir.
Okay, it's fine.
Yeah, the green roof and that layers we meant in the elevation.
Okay, no problem. The last thing I had was, how long are you going to take to construct this?
Sir, as per our mentioning, it is 1 year to construct.
Okay.
Maximum. And under extreme scenarios, like we are taking it on an average basis, and we have listed it to be in 1 year, the construction. And the dismantling and everything will surely be done in less than 1 year, but constructing will on an average 1 year.
Okay, fine.
And sir, we are also, in affordability basis, we are going for 3.5 to 4 crores, and that too we have included hydroponics as initial investment. And we are also considering the return of investment also, and including that also only we are saying that we are going for 3.5 to 5 crores. Excluding that and everything we are looking, it's again an affordable solution.
What is the transparent material that you couldn't find?
Yes, sir. To be very honest, the material was a little confused. Like, we don't want it to be that transparent such that it disturbs the lighting level inside of people. And we needed it a little translucent, but we couldn't find it at the last time due to some issues, and we closed it up with the material. We got it from the nearby store. That was how it was. But every part.
What was the original material that you had in mind? Do you know what it is?
It was actually very translucent material, resistant, synthetic.
Iced polymer type sheet that can project patterns into the when the light hits through.
Okay.
Okay, thank you. Thank you, jury members. Thank you, team.
Thank you, sir. Thank you, everybody.
So we'll take a 5-minute break. And So the next team who is going to present is the fourth team, and the team is Team Saksham. They have worked on project Nirabra in Assam. So team, you will have 20 minutes for your presentation. On the 15th minute, I will give you a signal like this, and you won't have a 21st minute, which means I'll stop you at the 20th minute. And after that, you'll have a 10-minute Q&A with the jury. So keep your answers direct and to the point. So you guys are ready? Can you go on slideshow mode? Open your file and go on slideshow mode.
Hello, hello.
Okay, your time starts now.
Yeah, good morning, jurors and one and all present here. We are Team Saksham and we are proud to present you Nirabra, a community resilient shelter designed for Assam. My name is Tanisha Kotian and I'm team lead of Saksham. Along with me, I have Anushka Gangane, Reema Bal and Rutesh. Every year, nearly 2 million people in Assam are displaced due to reoccurring floods. In Nagaon district, river swells beyond control, leaving behind devastations. One of the local told us, we lost everything every year. We just start over. This word inspired us to create a solution that is not temporary but transformational. We are Team Saksham, a multidisciplinary team of architecture students and engineering students of third year. Each bring us unique skills, research and structure and sustainability to co-create Nirabra.
Our site is located in Fakali village, Nagaon, Assam, nestled in a natural drainage bowl. Monsoon runoff from Shivalik ranges floods the Brahmaputra, while water from North Kachar ranges feeds Kopili, all converging near the site. This low-lying area experiences frequent flooding, with its peak flooding at 62.1 meter in 2022. Flood mapping shows multiple retention forms forming in and around the site over the years.
The site is situated in a 1.5 meter depression between two existing ponds. Over the years, it has experienced increasing water accumulation, evolving from the temporary water body formation to significant waterlogging. The site lies in a warm and humid climate and receiving around 1,722 mm annual rainfall and an average temperature of 24.7 degrees Celsius. Wind speeds stay around 1 meter per second, mainly from the east and northeast. With 86.5% relative humidity, this factor guided us for a climate responsive design.
The region thrives on agriculture, supported by fishing and weaving. Children regularly attend school and faculty plays a vital role in shaping young minds. Then the floods arrive. Fields flood, homes collapse, and sanitation fails. Schools are shut down or are turned into temporary shelters. With roads underwater, children can't attend school. Economic pressures forces families to withdraw them from the school, pushing them back into work instead. Floods don't just damage buildings, they disrupt education and futures.
This project follows the PPP model, a people's participatory project, where the community is actively involved in shaping the design based on their real needs. Through discussion, they help us define what matters the most: safety, comfort, and ease of maintenance. By involving them in both creation and annual upkeep, the shelter becomes a space of ownership and pride, not just a structure. Our vision is to build a shelter that protect, heals, empower, and save during floods, and useful every day. Built with bamboo and community voices and nature-based solution, Nirabra helps villages not just to survive disasters, but grow stronger after them. Resilience made a way of life.
Our initial step towards resilience was making the site resilient itself. At the site's entry, we have a water station that provides clean drinking water during post-flood recovery. A bamboo grove that holds the soil, reflects local material, and can also be used in workshop. A dynamic playground supports students' physical health and also provides a breakout space where diverse activities can be accommodated. In collaboration with architect Bhola Shah, we designed eco-friendly biodikes using bamboo sandbags and soil. These structures integrate with site's natural terrain and prevent flood watering from entering the site. Supported by riparian plants such as Alternanthera reinecki, Echinodoris cordifolus, vetiver, areca palm, and jackfruit trees, the biodikes become stronger over time. This approach enhances biodiversity while providing effective protection for the community through a nature-based design. The bamboo pavilion during floods becomes a vital waiting area, offering safety and comfort to the elderly and children as they wait for the setup of modular shelter pods. While in normal time, it transforms into a vibrant space for workshop, learning, and community gatherings. The playscape is a vibrant place for children built from leftover bamboo joinery waste. In normal time, it fosters play and learning, while during floods, it converts into isolation room that helps preventing contagious diseases. A retention pond acts as a soak-away, while bioswales guide the runoff into the retention ponds, managing water naturally on site.
To measure a flood, we are using a BMP 180, which is manufactured by Bosch, a pressure sensor. By using a simple formula called pressure is equal to H into rho into G, where pressure we are measuring via sensors, and H is the height of a water, basically flood height, and the other two are the constant for the water. Component we are used for this, it is a totally generally available component. First one is a ESP32, and it is act as a primary controller and a communication module for our pressure sensor, and a BMP 180, then solar panel for a charging, and a battery. It is a LiPo battery for a long life, and a boost converter to boost the battery voltage up to 5 volt, because the ESP32 operates on a 5 volt signal. All these sensors are kept inside this closed vessel, so the sensors and electronics part doesn't get damaged. In future, we are trying to waterproofing them by using a acrylic coating and all. So what happens if we place the sensors upside down at near to the river or any ponds? If the water level rises because of the volume of the water, the elastic membrane gets compressed, and the inside pressure is developed. The pressure is developed inside, and we are measuring that pressure. And by the change of a pressure, we can predict what is the height of a water outside this vessel. So we can use this data to communicate the rescue centers that amount of water level is reached. You can help us, and we can create an alarm for that also.
Coming to the design, on 4,070 square meter site with 6,105 square meter permissible built up area, we have just consumed 450 square meters with 950 square meter construction area, meeting our project partner needs for a modular and replicable design. It serves around 275 people and shelters around 250 people during floods. The design elevates the structure to avoid flood risk and extend it for smooth circulation. The mass is splitted up and rotated to align with prevailing winds direction, enhancing ventilation and creating staggered niches to accommodate more people during emergency. A 35-degree slope efficiently drains Assam heavy rainfall, preventing water stagnation. This dual-level planning prioritizes resilience and inclusivity. At 3-meter level, the layout accommodates classroom, multipurpose hall, and essential facilities, promoting learning and sheltering. Rising to 7-meter, we have integrated segregated classroom zones and open areas, ensuring safety, privacy, and accessibility, designed not just to house but to empower the communities. Talking about the classroom design, when the disaster strikes, the classroom instantly converts into a relief shelter for 36 people. Wall-mounted pods are deployed once the flexible furnitures are cleared. Outside the emergency, it remains a bright, comfortable learning spaces designed for interactions and adaptability. Talking about the semi-open areas, during disaster, they become essential support zones, enabling quick, safe assembly with canopies and staggered walls, providing protection from rain and harsh weather. The building staggered design forms semi-open, spilled-out spaces that extend classroom into shaded areas. The next semi-open net area serve as a dual purpose. During disaster, it acts as a safe shelter and relief zone, comfortably accommodating around 25 people for immediate support and care. In everyday school use, it becomes an play area, read, engage in various activities so that children could engage in various schooling activities, fostering creativity and social interaction in an open, flexible environment. Multipurpose area. During disaster, the multipurpose area transformed into a critical relief zone for the flood distribution, safe gathering, and temporary shelter. Its spacious layout and easy accessible support efficient crowd management and emergency response. In every life, this flexible open spaces host school assemblies, events, festival celebration, and fosters community engagement and serving as a vibrant hub for students' activity. Following are some of the section and elevations showcasing different levels of activities across all the areas. This is the small animation how the normal scenario gets converted into floods and how our building is getting adapting to the situation.
Now the question arises, why bamboo? We chose bamboo for its rapid growth, carbon dioxide absorption, and tensile strength, which is 18 times stronger than steel. It's eco-friendly, reusable, and supports local jobs. Structurally, its flexibility and lightweight helps in earthquake resilience. Tapered bamboo columns, deep piles, and 45-degree haunches efficiently handle seismic loads. Unlike rigid concrete, bamboo allows controlled lateral movement without cracking. The slab of the classrooms, originally a two-way slab, is restructured using secondary bamboo cluster beams to divide it into 3 one-way slabs. These cluster bamboo beams offer high bending resistance and ensure uniform load distribution. For the walling system, we have used bamboo frames filled with rice husk and coated with wire mesh and lime plaster, creating lightweight yet durable walling system that ensures thermal comfort.
The pod system is central to the dual-purpose community resilience shelter, functioning as a school and converting into a flood-time shelter. These modular pods are structurally resilient and spatially flexible. Typically for single users, they can accommodate 2 during emergencies, balancing space and safety. They also serve during disease outbreaks and post-disaster recovery, offering privacy and psychological comfort in a shared environment. Joinery-based assembly enables quick setup and reconfiguration for changing needs. Bamboo construction waste and fish cut joinery offcuts are reused as facade partitions for a playscape. Local vetiver grass is used for partitions and blinds, improving thermal comfort and air quality. Making these blinds involves the community and can be part as well for student workshops. Elevated shaded storage units keep essential supplies dry and accessible during floods. Swings used during school convert into floating rafts during emergencies, supporting evacuation. We have also created an app and a website to inculcate and teach sustainability for the students from early on.
This slide showcases environmental strategies for health and well-being. Low VOC bamboo improves air quality while operable windows and breathable walls enhances ventilation. Vetiver blinds, orientation, and daylight simulation ensure glare-free lighting. Thermal comfort is achieved through passive design strategies and proposed uniform with a flow rate of 0.5. The slide highlights communal and behavioral well-being. Waste segregation is ensured through color-coded bins and pictorial signages. Inclusive spaces, cultural elements, and accessible paths support community health. Hygiene is promoted via daylit, gender-segregated toilets, multilineal signages, and natural cleaning products. Nourishment is encouraged through sustainable dining and semi-open area, shaded spaces as well. These slides illustrate how the design supports physical and mental well-being in both everyday and disaster use. Playscape, pavilion, and open areas encourage physical activities, while calming nooks and accessible spaces foster mental well-being. In emergency, the structures adopt with medical rooms, segregated zones, and private pods, ensuring dignity, hygiene, and emotional stability. Talking about energy performance, the design demonstrates exemplary energy efficiency, reducing energy use from 19,013.5 kilowatt hours to 9,192 kilowatt hours, achieving a 52.38% drop and an improved EPI of 20 kilowatt hour meter square per year. Through LED fixtures, passive design strategies, and optimal window orientation, we minimize lighting and equipment loads. Daylight simulation shows 89.3% of spaces achieve 100 to 2000 lux. The envelope features low U values of 0.53 for walls and 0.21 for roofing, cutting internal heat gains. Powered by solar panel array, the site achieves 100% renewable energy with a 3-day battery backup, ensuring a net zero readiness.
In our flood-prone region, efficient water management is critical. Our system smartly allocates water for drinking, cooking, bathing, and irrigation. Grey water is filtered and reused, while black water is treated using a raised vertical reed bed system to ensure functionality during floods. We rely primarily on rooftop rainwater harvesting filtered through a multi-stage system using sand, charcoal, and gravel, ensuring safe on-site water treatment. A key innovation is the buoyancy-based water tank constructed with sealed gallon drums and guided by bamboo, which floats during floods, maintaining access. To reduce consumption, low-flow fixtures cut usage from 90 liters to 42.1 liters per person per day during disaster times. The strategically located water station at the site entrance provides safe potable water to the community when conventional sources fail. This decentralized self-sustaining system ensures water security through practical flood-resilient design. To cut embodied carbon drastically, we used 4 key strategies: simplifying construction to use less material and energy, choosing low-emission materials, using renewable energy, and reusing waste. Our materials like bamboo, rice, husk, and thatch were locally sourced and needed minimal processing, reducing emissions further. This approach helped us lower embodied carbon significantly by 94.8%.
We've addressed resilience through 3 stages: impact, adapt, and evolve. Health resilience ensures segregation through efficient space planning, and bio-toilet kits may be provided for post-flood recovery. Adaptive resilience uses tilted areas for cattle safety and later on gathering zones or workshops. Energy resilience enables a net zero cycle with 3-day battery backup during floods. CCB treated bamboo achieves a 40-minute fire rating. Pre-stored grains for disaster situation empower farmers, and rental exhibition may showcase workshop-made crafts. Resilient ponds and skills gained from the bamboo workshop support quick post-flood recovery. Buoyancy-based tanks and Nirabhra app ensure reliable water saving and management. Affordability is achieved through locally sourced Dimapur bamboo at rupees 18 per running feet against Guwahati bamboo at rupees 28 per running feet, along with material efficiency, foldable furniture, and investing in energy and water savings. The total project cost is rupees 15.46 million. The cost per square meter is rupees 16,587, and there is a 39.26% cost reduction compared to the base case.
Our multifunctional modular design ensures seamless use of both the school and disaster shelter, enabling uninterrupted learning even during floods. It benefits both the user and the project partner across the 3-dimensional features such as design, community, environment, and economics. While the user gains safety, dignity, and empowerment through bamboo workshops and adaptable spaces, project partner gains economic benefits. Built using locally sourced material, it's a net zero energy, water positive, and reduce CO2 emission by 94%, offering a resilient, climate responsive, and a future ready solution. As we close, we return to the heart of Nirabhra, that is the community. This isn't just a shelter, it's a living system of learning, healing, and growing. It's a seed of resilience rooted in local wisdom and built with dignity. Nirabhra doesn't just react to disaster, it's ready for them. Adapting with the people, it serves every choice from bamboo joinery to floating tanks. It's made with care, empathy, and purpose. This is not just a shelter, it's a seed of resilience. And this is why Nirabhra is the future you can choose today. Thank you.
Thank you, Team Saksham. Very nice presentation. We'll take comments from the jury. Piyush, you want to go first?
So, one is, I think that there's some really interesting parts to your work. But with respect to the design form and the material use, again, you have a lot of semi-open spaces. So the challenge in the design like yours is that the number of secure spaces is actually far lesser than the semi-open spaces. And to use these during regular times has some challenges, but it has even more challenges to use them during a high rainfall event, flooding kind of scenario, where people are looking for security, looking for shelter. That is one. Second is that your built form is such that while you're talking of slope, 30-degree slope, there are large sides of the building that are actually exposed. So if you have rainfall coming in at an angle from the other sides, your rainfall is actually going to go into your spaces and completely make them wet. So there are a couple of other comments, but I think for me, the third important thing is that while the use of bamboo is encouraged, and I think it's great that you're trying to use it extensively here, if you're really going to use it structurally for the kind of conditions here you have, I would have expected more detailing or more justification as to how the structural aspect of bamboo has been calculated, detailed, and at least the presentation, but even the report earlier, I didn't find that level of detail. Thanks.
Okay, so speaking about the most of the semi-open spaces as compared to the cover spaces, for the semi-open spaces, we have provided, as the concern was whether the rain would get affected the daily activity during the disaster time. So we have extended curtain vetiver blinds, which will protect them from the wind coming inside. And also the 35-degree slopes, which has been provided to the design, have both the side 4-meter overhangs, which shades all the semi-open spaces. Additional shading is provided with the curtains which can be pulled down during the disaster time. And for the bamboo joinery detail, talking with our industry partner, one of our industry partner who has been experienced in bamboo for past 35 years, we have discussed this bamboo joineries with him, and all our joinery details have been done in keeping the structural integrity in mind. Even for the foundation, we have went with a pad footing where the concrete based foundation is supported at a pad slab, and then the piles deep down the ground, so that even when the soil erosion is also one of the major problem in Assam, this helps in preventing them. Along with that, the columns used in the structures are tapering columns, starting with a 6-meter by 6-meter ka grid, 6 by 6 ka bamboo grid. It gets tapered at the top. So it acts as a pyramid which helps to distribute the loads evenly.
Shaili?
So guys, very good storytelling.
Thank
you. Good job with that. I had a question for your innovations that you are proposing. So one is the design innovation for storage that you're talking about.
Yeah.
So the question is primarily what type of storage are you anticipating? That's one. And second is by the design that you have at least mentioned in your report and even in the presentation at the moment, because I couldn't figure out the dimensions of the proposed shading device that you are recommending, right? That is there in the design. So first thing is, what is it that would be stored? That's one. And second, do you feel that it will be adequately protected? Because I don't think if in case of high rainfall, that space can be utilized as a storage space.
Yeah, so speaking about the storage space, it is provided inside the classroom area below the part, and what needs to be stored is, when we talk to the locals, they told us that when they come to the shelter, they bring their one luggage bag, which is a Lokhandwala typical bag with them, which they come. So for storing that spaces, we have created a niche below our window area, which comes out and create a depth of around 0.45 meters, so that their luggages can be easily accommodated over there, and it creates a bay window kind of a structure. So even during the school times, it can act as a bay window for the children to read or to engage any other activities. Talking about the shading devices, it's a occupant control shading devices. It's a bamboo joinery blinds where you can unfold it, close it according to the situation behind. It's fully occupant control. So it, as the first question was, well, what would be stored in those storage are the people who will bring the luggages along with them during the disaster time. And during the normal times, the children can keep their school bags and other stuffs inside them. And this projected bay window can, this projected part can act as a bay window. And the shading devices is a fully occupant control, which the occupant control, so it also eliminates the risk of the water seeping into the structure or inside the structure.
But the question still remains the same, like would it be adequately protected? I think you can, think of it internally and discuss. The second thing was about the rafts, the swings turned into a raft for commute. I think I have a lot of questions on the dimensions, but and also in terms of the operability, that how would it actually work. So also something that the team needs to think about.
Yeah.
So the swings provided in the sketch is just a schematic depiction. In the walkthrough for our site, we have shown how the swings are actually there. It is 1.5 by 1.8 meter, and they are over. It's not like a swing. It is just a suspended thing on the playscape. So that can be detached and that can be used as evacuation rafts.
Okay. Nice presentation, very impressive with a lot of animation and graphics and also good participation. But I would hope now that the others would also answer apart from you.
Yeah.
So that would be very better. So I have some questions which may take you a little bit into details, but I want to check that. How will you compact the rice husk?
So the
Somebody else can answer if possible? Okay, I'll leave it to you.
Yeah, so the rice husk is compacted similar to the ram earth. In Assam, they locally, what they do is how the ram earth has been compacted with the hammer, with the rod. Similarly, with some of the binding agents, the rice husk have been compacted. Using agents such as bitumen adhesives can be also been used, and local adhesives are also available. Currently, I'm not recalling the name of it, but those adhesives are added along with the rice husk and they are compacted. In our walling assembly, after the compaction, we have encased it with chicken mesh so that it won't leave its shape. And then we have done the bamboo matting, and then above it is the lime plaster cover.
The devil is in the details.
Sorry?
Rice husk cannot be compacted easily because it has got silica. So you have to be a little bit careful on that. Huh?
Okay.
And how do you arrive at no VOC at all? What are the chemicals that you're using? There is no volatile organic content
As of
at all?
such, we are currently not using any such paints inside our structure. Even the final finishing on the bamboos or the cashew nut oil, which has been painted on the bamboo for the aesthetic as well as for the insect resistant. So there are no, other than that, there are no VOC elements used inside the structures.
At all? Okay. Fine. I like the idea of you using the CCB instead of boric acid.
Yeah,
That's
boron, it's the
So CCB is basically copper chrome boron treatment. Boron itself gives fire resistant, and when treating it with all the three, we make the structure more durable. Along with that, it is then becoming a fungal or insect resistant with the treatment. So because of that, the structure longevity increases.
okay. Somebody else, maybe you can answer the next question. Dimapur is far away in Nagaland.
Yes.
And you say that's better than Guwahati or cheaper than Guwahati, which is just next door.
We've calculated the, during the embodied carbon calculations, we've calculated the distance to and fro from the site to Dimapur. That was the closest for bringing in the bamboo.
Okay, Dimapur is somewhere far away, no? Oh, okay. Oh, okay, fine. Okay, fine. And finally, the last question is, Are you happy with the payback period?
So talking about the playback period, we had a conversation with our project partner, and we wanted to propose many such events like rental spaces or something like that. But he specifically told us not to specify that because it is going to be a government school, and whatever the payback period is going to be calculated, it will be based on the electricity and water savings that we are going to do across the years. So he said that you don't have to do that, but in case you are expected to do, just calculate your payback period on the basis of these two categories.
And also the project is of Government of Assam, and it's funded by World Bank. So our project partner specified us to know this, use this as a grant to the project and not as a loan to the project. So it was a grant, and we have only removed the ROI for the water saving and electricity saving. So that is why it is 27 years.
Okay, thank you. Thank you, team. Thank you, team Saksham.
Thank you.
So we will now break for lunch. It's going to be a long break until 2:30 p.m. For folks online, I request you to tune back into this channel and be ready for the upcoming presentations. And the next team who will present is Team Resillex after the lunch break. So we'll meet you at 2:30 p.m. in this room. Thank you.
Solar decathlon, India, what's it all about? Net zero building, what's that all about? Solar decathlon, India, what's it all about? Net zero building, what's that all about? Is it cool? Is it hot? Is it drool? Is it fat? What's that all about? Real world problems need innovative solutions. If you don't act now, there will be implications. Is it hot? Is it cool? Global warming would be cruel. You will form a team with the same desire, going for the moonshot, forged by fire. We use technologies and crazy simulations. We learn to design with new innovations. So what you waiting for? No procrastination. Get off your butt, come join our workstation. Solar decathlon, India, what's it all about? Net zero building, what's that all about? These problems are tough and complex too. Your partners are there to help you get through. This challenge is exhausting, intense, it's a drill. These 10 mad contests will sharpen your skills. Net zero energy, water and stuff, and affordable too, that's crazy enough. Solar decathlon, and yeah, heck, it's really tough, but your attitude and grit is more than enough. Get your hands dirty on real world projects. You're gonna learn more than your specialized subjects. Solar decathlon, India, what's it all about? Net zero building, what's that all about? Cutting edge, butting edge, climate wedge, make a pledge. Do it all, save it for a lonely planet after all. Understand, climate friend, take a stand, make a trend. In the end, recommend, your ideas will have defend. Are you hot? Are you cool? Are you gonna be a fool? Zero heroes are here to stay. So what you waiting for? Come join this play. Net zero building, that's what it's about. Solar decathlon, India, that's what it's about. SDI.
Pick a site on a railway track. Put your building on an earthquake crack. Cutting million trees and planting roads and houses with their electrical loads. Dumb ways to build, so many dumb ways to build. Dumb ways to build, so many dumb ways to build. Put your building facing west. Make a toast of every guest. Concrete, steel, here and there. Carbon emissions to poison the air. Dumb ways to build, so many dumb ways to build. Dumb ways to build, so many dumb ways to build. Forget to put a bathroom elevator shafts that taper down, bad staircase trip over your gown. Dumb ways to build, so many dumb ways to build. Dumb ways to build, so many dumb ways to build. Start building with no hard hat, walk barefoot, toes go splat. No gloves on, no goggles too. I wonder what these wires do. Dumb ways to build, so many dumb ways to build. Dumb ways to build, so many dumb ways to build. Building on a melting glacier or a floodplain, letting all your rainwater run down the drain. Heat the earth enough to fry eggs on the sidewalk, with homes that must have ACs always running. These mistakes we make are all avoidable, and that is why we must let go of these dumb ways to build. Dumb ways to build. Dumb ways to build. So many dumb ways to build.
Build less, build smart. A message from Solar Decathlon India.
The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI. so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world's so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. world's so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world's so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through.
So welcome back everybody to the CRS division presentations. Next, for the fifth team, we have team Resillex, who will be presenting next. They have worked on a micro flood shelter in Assam. So team, just a quick reminder on the instructions. You have 20 minutes to present your work. 15 minutes I'll ring a bell like this, and you won't have a 21st minute, so which means I'll stop you at the 20th minute. After that we'll have a 10-minute Q&A with the jury members. Keep your answers short and to the point. So can you open up your presentation? Yeah, it's on slideshow mode. Okay, all the best. Your time starts now.
Good afternoon, everyone. I am Vishnu. This is Aparna, Deepika, and Ramadevi. We are from Team Resillex, and we're gonna present our solution now. Water floods. Floods are caused by overflowing of water onto dry lands. This usually happens due to heavy rainfall or overflowing of water or canals. Majorly coastal areas and riverbed areas are affected due to flooding. Every year, flood hit Assam badly. In 2022 alone, over 9 million people were affected. Drenched each year by relentless floods, Assam stands not just in water, but in urgent need of resilient hope and shelter. In Fakali village, Nagaon district, raising waters damage homes and displaced families during the monsoon. This project aims to create a flood resilient community shelter that offers safety, support, and hope during such disaster. So we have analyzed basic proximities to water bodies from the site, like which can cause major damage to the site during flooding. So there is an adjacent canal to the site just above the site, and there is another canal just 400 meters from the site. So by these assumptions, we have tried to simulate streamline order map. So different color showcases the different directions that water flow when rain falls, and these white lines intersection points show where water gonna retain. Thank you. So this is the flood simulation that we have done for GIS using GIS mapping. So the lowest elevation of the site is 56 meters and highest elevation of the site is 57 meters. But highest ever recorded flood elevation is of 62 meters, which is in 1973.
So, architecturally, the building follows a linear layout to maximize cross ventilation and daylighting. Strategic cross ventilation, strategic cutouts between volumes accelerate airflow. The final iteration integrates skylights and interactive zones to boost natural lighting and encourage user interaction. Nestled on 4,300 square meters of flood-prone land, the site demands resilience. The main entry is from the village road, which connects the main Kanpur road and the village. The site balances built mass, green buffers, and circulation path, accessible even in emergencies. Along the natural slope of the sites, we've proposed a bioswale, which will drain the flood water away from the site. Next, we have provided a park area for children, seating along the swales for the community, and a dedicated parking area for service vehicles during emergencies is provided. The landscape is zoned with native species, the zone in different zones. The zone A slows surface runoff, and zone B stabilizes soil, serves as windbreaks, and zone C and D provides shade and repel mosquitoes. Every element for planting to paving supports ecological resilience. Starting at the still floor, upon a 1.2 meter high plinth, this emergency evacuation zone allows flood water to pass beneath the core structures without damaging it. During crisis, it serves as a safe space for immediate sheltering and movement. Outside disaster time, it transforms into a live public realm, hosting community hearts, cultural events, or shaded gathering spaces, becoming the social heart of the shelter. The mezzanine floor then provides elevated refuge for livestock during floods, with dedicated zones for animals feed, safe ramp access. When not in use for emergencies, this space converts into storage space. Then next, the first floor and the second floor together accommodates up to 250 evacuees, with carefully planned zone for privacy, hygiene, and mental well-being. The first floor includes a medical room, kitchen, and a general sensitive central zone to support comfort and care, especially for women and children. Beyond emergencies, it functions as a wellness hub, offering maternal care, health checkups, self-help group sessions, and childcare area. And then the second floor acts as a disaster coordination center with spaces for relief workers, additional evacuees, and access to fresh food via an integrated vertical garden area. Year around, it promotes skill development, sustainability through organic farming workshops, seed exchange, and hands-on training for the youth. So these are the details of the section and exploded view of the different functions in the space. Our vertical garden system with wall-mounted planter boxes located within the garden area grows fast local crops, supported by gravity-fed drip irrigation system. It ensures nutrition security during disasters and serves as a live learning space during normal days. Ultimately, the shelter design is simple, easy to maintain, yet effective and practical.
Next, coming to the engineering aspect, we have proposed a pile foundation as our site has a alluvial soil which is resistant to water logging and scoring. Here are the details of the piles, pile foundation layout, and details of column. During the excavation, we have proposed 10-degree slope to prevent soil erosion. This soil is reused for landscape and plinth filling. While construction, the site is zoned according to the spaces. For instance, vehicle loading and unloading is proposed near the site for feasibility. Our construction materials are 80% of our construction materials are locally sourced. And the waste of these materials are reused inside itself. For instance, fly ash brick debris are reused on site as pathway subbase. The cattle waste management, which is produced during the emergency condition, is converted into vermicompost, and that is used for landscaping on site, vertical gardens, and the compost is packed as bag and sell to local community for revenue. Next, during July-August months, flood occurrence is mostly twice compared to the other months in annual period. Here are the two conditions how the energy is supplied to the building in emergency condition and non-emergency condition. In non-emergency condition, we have provided bi-directional meters so that the power is supplied to grid, and we can generate energy from grid. Our building stays cool, bright, and well ventilated on its own without using much electricity. The passive design strategies or orientation of building is towards prevailing winds, that is southwest. Cross ventilation, overhangs which protect from direct rain, fly ash bricks which is better insulation and moisture resistant. Bamboo screens which provide natural ventilation and lighting. Still not only provide structural support but also provide better airflow. The EPI of the building, baseline EPI is 41 kilowatt hour per meter square per year. It is reduced to 21 kilowatt hour per meter square per year is due to passive design strategies and efficient fixtures we have proposed. On-site renewable energy is bifacial solar panels, and the total we have provided backup energy for 7 days of 50% load. That the 50% backup powers essentials like CCTV, computer, common lighting in corridors, and 50% fixtures in halls.
In any disaster resilient design, water isn't just a resource, it's a lifeline. So our approach began by understanding how much exactly the water is needed for the community, both in daily life and during emergencies. So we've asked how can we do more with less. By using high efficiency fixtures like dual flush toilets and low flow fixtures, we cut down water demand by 40% without sacrificing comfort and hygiene. But reducing demand was only part of the story. Even in deficit months like December and January, when rainfall is low, we are prepared. We have seasonal water storage strategies like rainwater harvesting, grey water treatment plant, a 1 lakh liter emergency buffer tank, keeping water available during crisis. And here is the best part. The entire system doesn't just balance demand and supply, it goes beyond. We end up with a net positive surplus of over 4 million litre annually. This is the water cycle chart. Through smart demand reduction, integrated water loops, and seasonal storage strategies, we've achieved true water resilience. It's not just sustainable, it's self-sustaining.
Embodied carbon. Embodied carbon. Carbon emissions reduction. Here is a snapshot of our baseline emissions. Baseline emissions are up to 7.2 million kg carbon, and most of the carbon emissions are from traditional bricks and concrete. So we have thought, how will this happen? re- representing our approach to minimize carbon emissions. Coming to the wall, we have reduced up to 28.9% by using fly ash bricks, and floor we have reduced it to 62.5% by using cementitious flooring, and fenestration reduced it to 56.2% by using carbon, by using bamboo. Roof reduced it to 69.5% by using finished ashcrete, and structure reduced it to 55.3% by using ashcrete. Through thoughtful material selection and innovative construction, we have reduced 44% carbon emissions.
Next comes the resilient part. So the main concern is the flood resilience for our structure, with the canal directly located near to the site. So water accumulation due to the canal and risk of waterlogging are the main concerns. So we've proposed a stepped gabion retaining wall along the canal to avoid water from the canal. We have proposed permeable pavements in the hardscape to absorb extra runoff water. We have proposed bioswales along the edge of the site for easy water flow. The water is well managed in the site. And our zone comes under zone 5, high seismic risk zone. So we've proposed pile foundation, which will strengthen and stabilize the soil. And then we have RCC framing substructure, which will support further. And our form is a single structural form, which will strengthen the joints. And also the materials we've used are high grade ashcrete material, and also Fe500 steel, which will further strengthen the structural elements. For community and climate resilience, we've used passive design strategies, and for social issues, we've designed community spaces for people. For fire resilience, we have safe routes, fire safety units, zoned spaces, and accessible design ensure efficient evacuation during fires. We have autonomous systems, like solar power with battery backup ensures 7-day off-grid energy. And water, we are relying on storage, rainwater, and emergency reserves. The shelter can operate for 21 days. And for food, we have stockpile non-perishable to sustain occupants for days. Community kitchen with fuel efficient or solar cooking options. Vertical gardens for quick growing local vegetables and herbs.
Affordability. This table represents the total hard cost and total soft cost of the baseline estimate and proposed design estimate, which is reduced to 2,000 rupees per square meter. By using fly ashcrete and fly ash bricks, we have reduced it to 20 to 30% of wailing cost. By bamboo interventions like foldable chairs, bamboo partitions, and screens, we have reduced up to 50 to 60% compared to plastic or metal alternatives. And efficient fixtures are reduced to 20 to 25%, and BLDC appliances are reduced up to 45%. Solar panels offset to 1.5 to 2 tons CO2 per year, and SBI system is reduced to 15 to 20 rupees square meter annually.
So coming to collaboration and innovation, our first proposal is flexible bamboo partition, where these can be deployed directly during disaster times. Like the structure is made of bamboo, and the curtains are made of jute material. So during disaster times, these act as partition walls between families and other people. And during non-disaster time, these same curtains can be used as floor mats. So our second proposal is flexible bamboo fold chair wall. So this partition wall can be used in activity area where workshops gonna happen on organic farming, etc. So people can take out these seats and deploy it like that. And after completing the usage, they can again keep it in the partition wall again. Yeah. So we have proposed our third proposal is Gram Mitra mobile app. So this is like where everything information about Resillex Center and the workshops what gonna happen and the healthcare checkups etc. what gonna happen can be done. So in health and well-being, so we have achieved 0.5 to 1.5 meter per second inside airspeed, which is optimal. And in health and well-being, it's not only about technical details, it's also about mental health well-being. So we have proposed community areas like stepped seating areas and activities areas for the people well-being. And so for the continuous fresh air movement inside the building, we have tried to create stack effect at the double height zone. And we have tried to use operable bamboo windows around the building so that they can be closed or open at any time. Like during non-disaster times, they can be open completely for sunlight enter into the building. During disaster times, these can be closed, can be used only for partial ventilation and sunlight.
Adding value to the community. By accommodating 250 and livestock, we have provided well-integrated spaces, medical room and toilets, and clear emergency mapping. For the year-round utility, we have provided workshop areas and also activity rooms. For the emotional well-being, we have provided vertical gardens, stepped seating, and park for children, and also seating near swales. For the value for the World Bank, our shelter directly aligns with World Bank Climate Change Action Plan targeting resilient infrastructure and community-led adaptation. This shelter can be replicated in high-risk flood zones with low tech and low local materials, which is scalable and replicable. Following legacy and policy leverage, it becomes high visibility for the World Bank success story, influencing to build such shelters in similar regions. And coming to the financial value, our construction, reducing construction cost by 45% can be benefiting the World Bank. And for the environment, value adding to the environment, we are achieving 44% reduction in embodied carbon through local carbon materials like ashtray blocks, bamboo, and powered by on-site renewable energy along with implements of net zero water strategies.
So yeah, Resillex is not just a flood shelter. It's a beacon of survival, dignity, and renewal. In a region where floods disrupt lives year after year, we designed a space that does more than just protect. It empowers, it heals, it connects, and it sustains. By integrating climate resilience, net zero strategies, and community livelihoods, Resillex transforms a crisis response structure into a year-round community catalyst, one that's rooted in local culture, materials, and aspirations. We believe this model can be replicated, adapted, and most importantly, owned by the very people it's meant to serve. Thank you.
Thank you, team. You finished well on time. So, Piyush, you want to go first? Okay, Isaac.
So good. I think you've done a good teamwork, and all of you spoke quite well. And it's all about Lux. Yeah? Resillex. A good attempt to give an integrated solution, both structural, non-structural, and also taking into account certain other things like the socio-economic realities also. Maybe I just have a few comments, and maybe I just like to ask you if, when you talk about affordability, bulk of the savings, it comes from the interest cost. Is it true? Or where does it come from?
Can you
The
repeat
bulk
the
of the savings in terms of affordability, where does it come from really?
I think sourcing of local materials and recruiting materials in large quantity can reduce the cost of the materials, I think so.
Okay, but in your table, it was really, I was seeing that it's basically the interest costs which actually gave the bulk of the savings. I'm not sure if you recollect that. Yeah?
We are not sure, sir.
Okay, fine. Then the other point is that the solar power is the same all through the year generated? Huh.
During March to June, it has high power generation.
Okay.
4.35.
Okay.
Average is 4.35 per solar panel.
Fine. And just one more question is, who will operate the app, the Gram Mitra app?
The local people, Fakali village.
They will be able to operate it.
Actually, what we thought is, when we have attended the project partner meet that will happen like before D1, so they were like, if the project approves by the World Bank, the project gonna deploy like around the Assam, like where are the flood shelter available, they gonna deploy same type of design in and around in Assam. So what we thought is, this app can be made connecting all the flood shelters across India if this design can be scalable. So we have proposed.
Yeah, who will operate it? That's important.
Either World Bank or the organizations that involve in that. Like we have tried to incorporate during non-disaster times, we tried to incorporate like health clinical centers and workshops, etc. Right, sir? So if in Fakali village, there is proper healthcare center which is 10 kilometers away. So during disaster times, it could be problematic for a pregnant woman to transport that long. So any hospital like Apollo, some big company tries to invest in that, like in the remote village. So they can convert their patients from this village to their main hospital. So like investments through investments, and the investors can maintain, I think so.
Fine. Perhaps maybe it requires a little more thought process into it. Okay.
So, guys, firstly, it was very good to see you talk about terms like annual sunlight exposure and spatial daylight autonomy in your daylighting assessment, which is something that I've not seen in most of the other reports. So good job with that. It's an advanced parameter which is very rarely used. So very good. Having said that, also in terms of your natural ventilation assessment, you are claiming that it's going to be, there's an airspeed of 0.5 to 1.5 meters per second, which will help in providing thermal comfort. So just one comment over there, when you talk about thermal comfort, it's always a combination of airspeed as well as temperature as well. So I would just, along with certain other parameters, but I just keep it very simple, it's temperature and air velocity both. So having said that, next time on, if you are attempting to do any kind of, or you're talking about thermal comfort, make sure that you're also looking into other parameters so that it's looked at in totality. Okay, so that's one comment. I wanted to actually ask you guys a little bit more about your innovations that you have put forth. So as I could see, this is a movable window that you have created, and I believe you also worked with a industry partner, right? From Luit Nirman. They are the guys with whom you had collaborated. Right. So I could see that your solutions are very, they are actually quite good. In a way, they're simple, and it's like simple and effective, right? It could be replicated, and it could be also multiplied very easily. But did you think about some, unconventional methods by which you can actually make use of their expertise in bamboo? Because I mean, having said that, currently these lure windows are, I think, what kind of uniqueness is it bringing in, or your other innovative factors that you're talking about?
We haven't mentioned about this. We have mentioned only three. One is about curtain system that can be deployed directly during disaster time, and other one is partition wall that can be used in activity area, and third one is the app that we have proposed.
Okay, so that is also along with your your industry partners, right? So even in that, let's say if you go to your partitions that are being proposed with the jute partitions, so currently what it seems is that it's being mounted on a wall, like it's taking support of that. So is it actually a standalone system? So basically my question is that when you say innovative solutions, I was just trying to understand that how well, like how unconventional it is at the moment.
Actually, it's a wall mounted, ma'am. So the screens we've used is made up of jute. So during the non-disaster time, they can remove the screens, and they can use it as a floor mats during the workshops and all. So that's the flexible thing, flexible function of the partition wall we've thought of.
Okay. Okay, thank you.
Thanks. So Team Resillex, I think some really interesting work. I liked the effort you put into flood simulation in the beginning, assessing what is the kind of risk for your site in terms of areas where flow and accumulation happens. I also liked your effort at the stream edge, developing a sort of bioengineering solution for the stream edge where you have starting with grasses and then other species. So I think this is really good. I also liked that you made a value proposition also for your client. So I thought that was very good to also think of what the client may be looking at, and you've been able to pick up some important terms. So I think that's really good. I think one one comment that I had is, at least in your earlier report, there didn't seem to be very explicit mention of how your building is earthquake resilient. Although now in the presentation you seem to have addressed it. So could you maybe tell a little more about how your building is earthquake resilient, or how you made it earthquake resilient?
So as we said earlier, we've used pile foundation system, and we've used a single linear form, and also for the substructure we've used conventional RCC material, so which is strong and earthquake resistant, and also the choice, the quality of materials like ashcrete, which is with high compressive strength like M30 grade, and also FE 400 reinforcement.
Yeah. So when you say because it's RCC is earthquake resilient, you know that's not exactly true, right? Even a RCC building can fail during an earthquake. So if you haven't detailed it out, or you haven't consulted with your, say, structural engineering partner, it's better to say that rather than say things like RCC is earthquake resilient.
Yes, sir. Actually, we've not fully consulted. I mean, we've not fully thought of earthquake resistance. We've only concentrated mainly about flood resilience. So that's that.
Okay. Do we have time? Is anybody else?
Maybe last question.
Anybody else wants to go? One more question was that, considering that you are in a high rainfall area, you decided to go for a flat RCC roof structure. So you've done a good detailing in terms of having continuous chajjas all floors, but why didn't you think of maybe doing a sloping roof like so many of the other groups have done?
So main thing is for easy management of solar power management, and also
for ease maintenance of the solar panels and battery storage, and even overhead tank we have placed on rooftop, and a half portion of the building is slope roofed. Even there solar panels are oriented towards southwest for better renewable energy, and the roof has a slope, a little bit slope for the rainwater to collect to the rainwater harvesting pit.
Yeah. Thank you, team. Thank you for your presentation. So we'll take 5 minutes and for the next team to present. So welcome back. For the next presentation, we have team number 6, Team Centtory, and they have worked on a micro flood resilience shelter project in Assam. So team, same instructions as before. You have 20 minutes for your presentation. At 15 minutes, I'll ring a bell like this. And you won't have 21st minutes, which means at the 20th minute you have to stop. And after that, we'll have a 10-minute Q&A with the jury. So keep your answers direct and to the point. So you guys are ready? All right. Your time starts now.
Good morning, good afternoon everyone. We are Team Centtory from IIT Kharagpur, and today we want to tell you about a building, not just in terms of walls, windows and roofs.
Serve both seamlessly.
That question led us to 3 design ideas. First, duality, because the same space must educate in calm and protect in crisis. Second, rootedness, because the solution must grow from the soil it's built on, in culture, in climate, and in construction. And third, resilient by design, because disaster isn't an afterthought, it's the blueprint.
Our proposal, the Community Resilience Shelter cum School, is more than a building. It's an approach, one that balances innovation with tradition, engineering with empathy, and performance with people.
Over the next few minutes, we'll show you how these 3 ideas were not just design principle, but design decisions. Now over to Shweta.
We began this project by understanding the land and lives of Kanpur town. This region is no stranger to heavy rains and seasonal flooding. It is, in the peak monsoon years, over 3 lakh peoples are affected. Entire villages are getting submerged. Farmlands are submerged for weeks. So who are these people here? They are everyday families, farmers, fishermen, and handloom weavers, settled near one of the Brahmaputra's many channels, the Kopili River. They live with the river and often suffers because of it. The Assam State Management Authority has officially marked Nagaon as a district with recurring flood emergency. Our site is located in the state of Assam on the edge of Kanpur town in Nagaon district, just along the Kopili River. As we saw, a zone highly subjected to seasonal flooding. Covering approximately 4,100 square meters, the land lies in a semi-urban zone characterized by predominantly resident uses interspersed with agricultural patches. Within 1 kilometer radius, we have essential community infrastructures like local market, the primary schools, and healthcare centers. The climate of the region is subtropical with high humidity, and we receive an annual rainfall of 771 mm. And for the recent year, May 2025, Assam has received heavy rainfall, more than what they usually receive, with gusty winds. Over to Chirag.
For the design development, we first started with basic massing, in which we took a symmetrical 2-story block with minimal openings. Then we introduced tilts for safety during flood hazard. Then we divided the mass to decrease vulnerability during earthquake. Then we introduced courtyards, which help with microclimate cooling, as well as daylight penetration. Then we optimized airflow by disjoining the built form. And then we provided cross bracings on the stilt floor and wind tower, which will act as thermal chimney. Then we introduced pitched roof, which as per the climatic conditions, and help with rainwater harvesting as well. And then vertical fins, which are horizontal louvers actually, on the southern facade of the building. Then we reached to the design, the final design. So in the site plan, you can see as we enter the site, there is a playground. Then comes the first block, in which there is entry foyer. Then on the left, there is admin. And on the right, there is kitchen and services. And then there are classrooms. And then we reach to the transition deck. And then library block and the left classrooms. And on the rear end, there is the multipurpose block. On the right, you can see these are the spaces that that are for the school. And on the color coded in the red, there is accommodation space for shelter. Then medical and services area, help desk in green, then storage spaces, and bathing and toilet spaces. Then the first floor plan of school, there are 6 staircases and one ramp through which we can access this flow. I have already told you the planning. Then in case of school, this will be the layout. And in case of resilient shelter, this will be the layout. The classroom spaces will turn into sleeping areas, and the corridors will be accommodated along with that to increase the space. And then this is a section in which it shows the structural system of the building with structural bracing and horizontal louvers system, which we have the component model as well. And then roofing member tile and trusses in the roof. And then for second floor plan, the area open terrace turns into evacuation zone. Now Aniket will tell about engineering and operations.
So these are some photos of our projects. So coming to engineering and operation, to ensure a structural simulation, we used the 10.8 version of StatPro, and we designed the RC and steel structure according to it. We used the IS code of 456 2000 to ensure the reliability of the steel structure. Also, we tested the maximum and minimum reinforcement under different kinds of load condition to ensure our steel structure and RC structure should be safe. And as we mentioned earlier, our project is in the zone 5 of earthquake zone. So we use the IS 189-193 and ASCE 7 and Eurocode 8, which ensures that the project should be under the guidelines of zone 5 earthquake areas. So these are the coordinated site plan where we are proposing the sewage line, different kinds of lines like wastewater line, which is in the two types, grey water and black water. Also the runoff water, which will be collected from the rainwater, and we have the different pits to collect this water. So the wastewater which will be collected is transferred to a treatment plant, which is in our site project site. Now we have also proposed a few plants which are locally available, like sal tree, neem tree, people tree, which have the tendency to hold the soil to reduce the soil corrosion. So this is the site plan. In detail A, we are shown that there is a bamboo reinforced concrete column laid on the AAC walls, and in detail B, we are showing the roof side, which have the interlocked clay tiles and also the UV resistant tray. Our project site is in the danger zone of 60.5 meter from the mean sea level. So we are giving a safety buffer as a 3 meter distance. So you can see in the section X, the construction has been done from the first level, and the difference between the ground level and the first level is of 3 meters for a safety buffer. So these are the more specification of our project. We are given the solar panel on the southern, eastern and western side of the roof. Also the bamboo trusses, AAC blocks and terrazzo floorings. And also the localite clay tiles has been installed in the systems. So this is the project timeline. We have proposed a timeline of 16 weeks, which has been divided into 6 phases. The first phase is the site preparation, and the second phase is the superstructure, where the beams and column will be done. The third phase will be the roof and floor completion. The fourth phase will be the building envelope. The fifth phase will be the MEP, which is the mechanical, electrical and pumping completion. And the last phase will be the handover and furnishing. So over to Shiv.
Moving on to collaborative innovations, we adopted bamboo reinforced concrete as an emerging sustainable construction technique that replaces the conventional steel in reinforcement with treated bamboo as a key structural innovation. The technology drastically reduced carbon footprint while enhancing the local adaptability. In collaboration with IIT Kharagpur ARP department, we integrated BRC into the core framework of the school cum shelter. This shows the completed project of IIT KGP, where they have used the bamboo reinforced concrete. And we also attended a workshop teaching us the techniques of the reinforced bamboo concrete. Moving on to the light gauge steel frame. We selected the light gauge steel frame, or LGSF, for its exponential performance in both seismic and flood-prone contexts. Its lightweight nature minimizes foundation stress, particularly critical in soft, flood-affected soils, while its tensile strengths provide stability during earthquakes. And we have a multidisciplinary team with the team roles varying from sustainable architects, structural engineers, environmental engineers, mechanical engineers, and city planners. Moving on to health and well-being, we have this chart showing the heat balance, the relative humidity, temperature variation, and discomfort chart. On the right side, we can see the daylight factor and the UDI simulation calculation. So in this, you can see the daylight factor for an entire flow plate of the design. On the right, you can see the daylight factor and the UDI calculation for a classroom. These simulation shows the external CFT simulations, which leads us to our inference. Okay. So we have achieved thermal comfort through stable indoor temperature, minimal discomfort hours, which was going to null, like almost zero, consistent heat balance by controlled heat gain and heat loss, acceptable relative humidity range, which was varying from 55 to 75%. And moving on to the daylight anatomy achievements, the peripheral workstations of the building are almost entirely using daylight. Most of the flow plates are having 100 to 2000 lux, which helps us attain a glare-free visual comfort. All the occupied zones exceed 2% DF benchmark. Natural ventilation, enhanced passive ventilation through courtyards, and wind pressure mitigation through roof overhangs and elevated slabs. Moving on to now.
As we can see in this graph, comparing the energy demand in the green color and the energy generated throughout the year in the red. Now, let us understand how we reached here. So, we began by adapting passive design strategies as the foundation of our energy performance. Taking cues from the climatic context of Nagaon district, we optimized the building's orientation, integrated extended overhangs, used ventilated facades to significantly reduce heat gain. Our goal was to reduce dependence on mechanical cooling while ensuring thermal comfort. This strategy, complemented by thermal mass and well-placed openings for cross ventilation, helped us achieve high levels of thermal comfort and daylight autonomy, as we have seen in our previous section. The choice of material for the outer skin was done in accordance with the Super ECBC guidelines. So the walls were made of AAC blocks with rock wool plaster. The roof assembly was, the roof materials were locally sourced, such as bamboo and clay tiles, which gives us a better performance than RCC. It also has a layer of rock wool insulation. Lastly, for the fenestration part, we used DGU, which uses air insulation in it, and we ensured reducing air gaps to reduce air leakages and maintaining thermal comfort. After that, for finalizing our external facade panels, we went to multiple iterations, keeping in mind its effect on our EPI and its cost and its integration in design. And after that, we finalized an optimized solution, which we can see as sliding and folding panels made of bamboo here in our component model.
Can you raise this a little bit so that we can see it? Is it too heavy?
Okay. So finally, to achieve this EPI target, we covered the rooftop with solar photovoltaic panel with an efficiency of 15%. The roof-mounted PV system is designed to meet the energy requirement during both the operations. And from that, we achieved the EPI of 10.33 kilowatt-hour per meter square year, which is even less than the Super ECBC standards. Now, coming to water performance, the water flow in the building, there are multiple water treatment plants located in the backside of the building, and there are two main water sources, which is the bowel and municipal corporation water. And for the water conservation, we used two main methods: using low flow fixtures to reduce our consumption by 20%, and treating grey and black water to ensure reuse of contaminated water. So let us understand the water cycle. So as I told you, the water comes from two main sources. First one is municipal corporation water, and the second one is bowel. From there, water goes to the overhead water tank. From there, the water is supplied for domestic usage, drinking, cooking, and flushing, etc. And then the water is, the grey water and black water generated are treated through multiple systems and used for, then the treated water is used for multiple purposes such as irrigation and groundwater recharge. So the total water treated in our site was around 2,400 kiloliters, and the total water discharged in the ground annually was 4,000 kiloliters. The whole site has drains at the edges to make sure the water in the site flows to the canal that leads to the Kopili river, which will lead to a reduced water level inside the site at the time of disaster, and it will take the benefit of the natural terrain. A major part of our sustainability effort also lies in the choices of material. So instead of conventional high carbon components, we used AAC blocks, bamboo composite panels, in situ terrazzo, bamboo truss, and as you saw, even our facade panels are made from bamboo members. Our material palette was locally sourced wherever possible, reducing transportation related emissions and encouraging community level economic resilience. Quantitatively, there was a significant drop in the embodied carbon emissions. As per comparative analysis, the proposed system led to a decrease of 65% in total embodied carbon. Those numbers validate our belief that climate resilient buildings can be both high performing and low impact. Now, let us know more about resilience from Zaranyu.
For seismic resilience, we provided bracing and lightweight LGSF flooring system, and then we connected the disjoint blocks via that only. For the flood resilience, we provided raised deck system and stilted plinth. Then economic and operational resilience, there is affordable construction. Then partnership with Delta Green gave us optimized project management, and community participation, which will involve SHGs. And adaptive cost allocation gives us balanced expenditure to execution and planning. And social and functional resilience, there is dual use design, which enhances year-round usability, inclusive design, which in terms of gender neutral toilets and universal accessible ramps, community kitchens, and training areas. And then hydrological and climate resilience, there is floodwater diversion. In terms of biospheres, there is rainwater harvesting and passive cooling systems. So cross bracing for structural resilience, and roofing with area on the southern, eastern and western side of the pitched roof. It offers off-grid functionality as rainwater harvesting does the same. In the right, this is a schematic diagram that shows the key area for resilience. The first phase is pre-flood phase, which ensures normal school functioning. Daily use, there are classroom, and there are passive systems which we have provided. Then in preparedness mode, we will keep relief supply stored in elevated compartments. Then the second phase, alert phase, evacuation drill will be initiated, students will be dispersed, space conversion begins, desks and benches will be moved to make space for beds, utilities will be secured, and flood barriers installed. During flood phase, community access will be opened, design features will be in action, zoning will be activated. In terms of classroom, sleeping zone, distribution aid center will from assembly hall, and staff room will turn into help desk. Then post-flood, there is water draining and site cleaning, disinfection and minor repairs, furniture restored, feedback session will be held to assess the damage. Modular furniture and its application are shown here, such as a retractable staircase and beds that turn into table. Now Aniket will tell about affordability.
For affordability, we did in two parts, a hard cost and a soft cost. So as you can see, apart from the land, all the cost which we have been proposed is cheaper than the estimated cost, which is the baseline cost. And we have proposed a cost of 40,956 square meter, which is 12% cheaper than the nominal kind of typical flood shelter. The flood shelter which we did can accommodate at least 280 people at its best of condition.
Moving on to value proposition, our design was deeply inspired from the Changar which is a stilted bamboo structure long used by the indigenous community to withstand floods. So our value proposition is designed to serve all three kinds of uses: the students, displaced families, and the developers. And for the developers and constructor, it is scalable model. They receive training in bamboo and steel techniques, while the lightweight modular structure shortens the construction timeline and lower cost by 40%.
When we began, we told you our project was rooted in 3 ideas: duality, rootedness, and being resilient by design.
Today you have seen what that really means. You have seen how one space becomes a school and a shelter.
In Nagaon, this building will mean safety, learning, and dignity all under one roof. But to us, it also represents what design should be: practical, human, and deeply hopeful.
Thank you.
Excellent presentation, team. Now we'll take comments from the jury. Shaili, you want to go first?
Guys, you've presented it really well. I mean, it was so smooth transitioning from one person to the other. It was really good. So you guys were very well prepared. So that's great. And also I could see, it was very good to see the parametric assessment that you have performed. And I think it was not there in the report. So maybe you have done it in such a short period of time, which is great.
It was
it was in the annexure, maybe it wasn't there in the main part of the report. Okay, so maybe which, I mean, out of that iterative process that you guys have taken up, like how did you come up to a decision that this is what you want to do? If you could also emphasize a bit on that.
Yes, ma'am. So as I told you, there were multiple parameters such as the openings effect on our EPI, like how much light it will intake. So as we saw multiple iterations, so those were like very near in their data. So the amount of changes in EPI they each of them gave was very close. So one other factor was also cost. So as we saw, like as we have used bamboo, so this was the possible shape that was easy to make and cheap to source from local areas. So that was also considered while finalizing this form.
Okay. And also, you guys mentioned about using a double glazed unit. But I guess your fenestrations are already very well shaded. So,
to ensure the thermal comfort, we used double glazed units, and that's how we performed the calculations. So, in that, it showed it's needed in that area.
because it will also have a big impact on the costing aspect if you're using a double glazed unit. So if you are able to well shade your fenestrations and openings, it will like an added on cost that you're kind of doing. So that can be one thing that can be eliminated. Okay. Yeah.
Thank you, Shaili, Isaac. Yep.
Yeah, I think I echo what Shaili said about your smooth presentation. It's been quite a good job. But I want to stretch a little bit. Do you think about the end of life of all the components? For example, bamboo reinforced concrete, for example.
So actually, this is still like under research phase. Like there are projects implemented.
Your mic is not working properly. Probably, I don't know.
Hello?
Yeah.
Yes, sir. So bamboo reinforced concrete is still under research phase from our institute only. So for end of life, we have to see a project that has been built for years. There are new projects only. So we couldn't go into that depth for this.
Okay. And also you have a lot of stuff which basically has composite structures.
Yes, sir.
Right? So all that is actually very important when you come to end of life.
Okay, sir.
So just take care of that particular aspect. I think you've done quite a good job on many things. Did you think about the waste management aspects?
So for the school and resilient part, there will be very small amount of waste generated. So that is not like feasible to treat inside the site. So it will be transported outside the site. So like inside the site, we haven't thought about that.
Okay.
And so also to add to your point of end of life, apart from bamboo reinforced concrete, there was light gauge steel frames.
Yes.
So steel is very much.
That's okay. I'm not bothered about. That is okay. That's fine. I'm talking about the other composite structures, basically.
Thank you, Isaac. Piyush.
Yeah, so I won't repeat the fact that I think it was a really smooth presentation and very comprehensive. I liked a lot of parts. But there are 2-3 things that I had also raised in my comments and I want you all to respond to. So one is that while I understand the pull towards Mangalore tiles, in reality, if you look at the usage of Mangalore tiles in Assam, it's not really a local material, or at least in buildings, you won't really find Mangalore tiles. You'll find a lot of GI sheet, and now people have transitioned to manufactured, those sheets. So that's something that I was a little concerned about. And the second thing is that you have this transition space between the front building and the back building. And I think you have, after maybe the comments, tried to cover it. Because in some sense, the same earlier comments have been giving that, you really have to think of how these spaces become during rains. So that space is an interesting space to have, but it's also a weaker space from the perspective of movement, especially during rainfall periods. So if you would comment on these two things, please. Thanks.
So can you repeat the first part?
The first one was on the use of Mangalore tiles as opposed to other options that are available.
So Mangalore tiles are increasingly available in that region and it is being locally produced. We contacted some of the vendors and we came to know that now they are being locally produced. So it is being promoted there and it will be probably in major use in the coming years. And for the next question.
So actually what that space holds the both the fire staircases, and through that there is a wall on that side. It's open only on the front side, which we also were like, we wanted to give us for architecture we wanted to give a semi-open feel, and then for resilient shelter we have thought to cover it as well, but it will be temporary only, and it's only exposed from one side. So we have tried to mitigate it, but I think we could have implemented more ideas to it.
Any other comments, questions?
If I can. So I like the way you talked about your multidisciplinary team and the fact that you've got inputs from different people. And I know it's not easy, but one of the comments I've been giving teams when I've been reviewing is to say, can you get a sociologist or a social worker or an anthropologist on your team, because you're really working with communities. And I know that in architecture schools or engineering schools, we don't have sociologists, but this is not a comment just to you all, it's a general comment. We should try and see if, even if not part of the team, you can get inputs from those domains, because a lot of things can become clearer if their inputs come in on certain aspects. Thanks.
Actually, we have a planner in our team as well. So he was robust with demographic data and data related to that. We couldn't go to the site, that was a demerit.
Also, I'd like to tell you one interesting thing. Although we couldn't have a sociologist in our team, I have a friend who works in Odisha State Disaster Management Authority. So we were in contact with her. She gave us some pointers about their community. We were not able to exactly replicate that, but we got many insights from her about the local people in Odisha. Although we implemented a project elsewhere, but we got multiple insights from her. So that was interesting.
Thank you team. Thank you jury members. So the next and final team to be presenting today is Team Yakairol, and their project is on a community school and a resilience shelter in Assam. So team, similar instructions just as the other teams. You have 20 minutes to present your work, and at the 15th minute I will ring a bell like this, and you won't have a 21st minute, so which means you have to stop at the 20th minute. After that, we'll have a 10-minute Q&A with the jury members, and so keep your answers direct and to the point, so that there is more time for discussion and questions by the jury. So you guys are ready? Okay. Your time starts now.
Good afternoon, everyone. We are Team Yakairol from Manipur Technical University, and I'm from Civil Engineering Department. Our project is Fakali Community School and Resilience Shelter, which is supported by Assam State Disaster Management Authority and the World Bank. And our industry partner is Architects Collaborative Assam. Next, moving to the problem, Assam faces dual threats, that is regular floods and school shutdowns. And our project is in Fakali, which is under the Rupahi subdivision of Nagaon district, Assam. And even if it has some infrastructures like educational building, it has no resilient infrastructure that can act as a shelter during flood. According to the Water Resource Department of Assam, 39.58% of Assam is flood prone, which is 4 times larger than the national average, that is 10.2%. The people of Fakali face many risks, especially the women, children, elderly, every year. Then next. Looking at this map, this is taken from a research paper of 2023. Here you can see that Nagaon is located slightly around the middle. And from here you can see that the flood vulnerability zone, the flood risk zones, and flood hazard zones, it is very high, and it belongs to the high and very high risk zone. And the fourth image is about the Rupahi subdivision, where the Fakali village is present. Here we see that, in Fakali village, the child density is very low. The net zone area is high, and in the LULC class, it belongs to the barren and agricultural land. And the household density is high. The women density is also high, and the proximity to health services and proximity to metal road is low. Next, these are the flood hazard indicators. And here we can see the topographic wetness index is high, and in the elevation, it is very low. The rainfall is also high in Fakali village. In the stream power index, it is very low, and the distance from river is below 1 kilometer. The slope in degree is also very low, and the geomorphic division, it suggests low infiltration. Moving to our responses, like our building can be used as 2 ways. First, as a shelter, and second, as a school. During normal time, it can be used as a school, supporting 60 students and 15 staffs. And during flood, it acts as a shelter for 80 evacuees per complaint. And we can increase the number of evacuees. If we want to increase the number of evacuees, we can replicate the building. Our building is built up on a constraint of 3,000 square feet with isolated footing and a rest plinth of 1.5 meter. It has enclosed staircase, solar-powered safety system. We also use rainwater harvesting system and constructed wetland for recycling of greywater. And the image shown here, this is the 3D rendered view of our building. This is the contour map. The building placement is done based on the contour map for easy drainage of water towards the water body. And the third image is the solar panel arrangement. Moving on to the next, we have technical design overview.
Good afternoon, all the
audience present here and the jury. I am Lanmin Chungham and I am from Civil Department and I'll be explaining a technical design overview. First, our structure is equipped with a raised RCC plinth of 1.5 meter, equipped with AAC walls, bamboo partitions, and our shelter or our structure is designed in such a way that it is flood and earthquake resilient due to the different components that we've used, and we have also presented the component here. And our building or our structure is equipped with a water reservoir, an underground water reservoir of 24,300 liter, which is gravity fed supply, and our building is equipped with a grey water wetland reuse system. And the energy that the building produces through solar is 15 kilowatt peak plus 40 kilowatt per hour battery, equipped with motion sensor, LED, and auto pump cut off with manual override. Here, the two drawings shows the electrical layout of the first floor and the second floor. This shows the bulbs, the placement of bulbs, of fans, and the floodlights that we have equipped. This shows the first floor layout plan as well as second floor layout plan. This includes all the classrooms, all the multipurpose hall, as well as the first aid and utility rooms with SPEAR compliance, which is the required for the washrooms and sanitation regards. And the third layout shows the foundation layout of our structure. And in this part, this is the place where this is the rough foundation of our underground water reservoir. And the fourth building shows the sectional elevation of our building. Here, the first shows the site elevation of our building, our elevation being 30 meter, and the second shows our wastewater treatment. This is the anaerobic baffle reactor, which acts as a primary treatment of wastewater, and the third shows the front elevation of the building, and the fourth building shows the cross-section of our constructed wetland. This acts as a secondary treatment for our wastewater treatment system. We have also done a structure analysis of, in a dynamic manner, the dynamic structure analysis of our building with the proposed model. And our building was found to be safe, and the fourth picture represents the result of our structural analysis. The first is the building height, and we have considered the forces that we have considered are the earthquake loads as well as the lateral load of the flood factors. And next, I hand over the mic to my friend Ashish.
Good afternoon, everyone. My name is Ashish Sharma from Manipur Technical University from Electrical Department. Now moving on to the performance metric. We have taken the weather data of Assam test board from the ECBC website and provide the input into the design builder to be more precise. From the simulation, we have achieved around solar generation of 19,288 kilowatt hour annually. But the ground reality may be different. And actually, the energy demand of our building is only 8,000 kilowatt hour, which is the plus point of our model. Now moving on to the thermal comfort. We have achieved thermal comfort of 22 degrees Celsius to 32 degrees Celsius through the natural ventilation on the average for 80% occupied hour. And lastly, moving on to the carbon footing. We have achieved a 49% reduction in the embodied carbon, and the operational carbon is net zero ready with the use of solar PV cell. Now, this graph represents the cooling load of our building of the annual simulation, and the right graph represents the annual energy consumption of our building. Now moving on to the thermal cooling.
Good afternoon. Myself, Derek from Mechanical Department of Team Yakairo. So today I'll be speaking on cooling design summary of our building. So the cooling design of our building is, the total cooling load is given as 147.5 kilowatt all across the building block. The cooling load says that the amount of heat that need to be removed from a room and to maintain a desired temperature. So this this value is achieved from the simulation of a design builder software, and the peak cooling load of a block. That is block one. Block one is nothing but it's a corridor of a building. Corridor of a building produces and achieves the cooling load of 24.38 kilowatt in total. And moving to the design flow rate. Design flow rate, we have achieved design flow rate of 6.53 meter cube per second all over a year. So next is maximum operative temperature is 31.11 degrees Celsius recorded on August afternoon. Lastly, it's a cooling load per area. It's 292.19 watt per meter square in average. So these two pictures shows the meso heat gain of our building. So our heat gain is majorly from the solar. So solar gains a lot of heat from 34.13 kilowatt, and light gains of 6.81, equipment gains of 3.98, and roof and ceiling gains of 2.31, and people gains 4.4 kilowatt. So the next slide is this is a model of a Vayu Prabha model of our building, and the simulation of a Vayu Prabha, it says that the a facade is faced with the high pressure, in which we can see the red lines, and the other two side is with the less pressure. And lastly, it's the sun part model of our design builder in the render view of our building. Next, I'll give my.
Hello, once again. This data shows the carbon emission or the emitted carbon of the structure. We have achieved 40% or 49% reduction in the emitted carbon comparing baseline as well as proposed model of our building. First, as you can see, we have in baseline model, the emitted carbon is 101.7 kg of carbon dioxide equivalent, and in the proposed, there is only 52.1 kg of carbon dioxide equivalent. Here are the necessary data. And about the cost and replicability of our structure, our capital cost for baseline is 2.057 crore, and proposed is 1.529 crore, saving up to 0.528 crores. That is almost approximately 26% save. And in life cycle operational savings for 25-year horizon baseline, we got 1.635 crore, and for proposed, we got 1.269 crore, saving up to 0.39 crores. That is approximately 23% in cost saving. And life cycle cost summary is 25 years baseline. For baseline is 3.695 crore, and for proposed is 2.799 crores, saving up to 0.896 crore, which is approximately 24% in cost saving. Here is the proposed project cost breakdown of our project. And for replicability, our building is in a modular structure. It's a simple and box design. So if for baseline, our cost per square meter is 67,545 meters squared, including the wastewater treatment system, ABR, and constructed wetland. And for proposed is 45,268 per meter squared, including ABR and constructed wetland. And for overall cost, it's 33% more cost effective. And it's scalable for flood-prone reasons like Dubri and Kashar. And here is the cost breakdown of our project. For total hard costs, we got 49% for baseline, and for proposed, we got 54%. And for total soft costs, we have 51%, and proposed design, we got 30%. There is 20% reduction in the cost. And for interest during construction, IDC, we got 48%, and we got 20 in baseline, and for proposed, we got 28%. And the total cost comes up to 4.19 crores. And for baseline, and for proposed, we got 2.81 crores. The community value that we give to our building is more than just a building. It's a system for survival, dignity, and progress. For day-to-day activities, we've got education in normal days, training, and for community use among the localites. And for emergency times, we got flood-ready shelter, severe sanitation, as well as lighting and security. It is built by locals and managed by community. And the message, last message that we want to give through our project is that a school today, a shelter tomorrow, a legacy for year. Thank you from Team Cairo.
Good presentation, team. We'll go to the jury. We'll start with you, Piyush.
So firstly, congratulations to making it to the stage, and we're very happy to have you from Manipur. We understand that you are a completely civil engineering or engineering university, so some of the architectural design inputs, like you would have also seen in today's presentations, may have been difficult to get. Having said that, there are 2-3 things that I really liked in your presentation today. One is that you started with some really good LULC sort of analysis using research papers, and there often are research papers on the kind of areas we're working on. So I think that was really good to get an overall sense of the kind of land use, the patterns of people, etc. That was very nice. I also thought your design was very simple, but and you've also tried to take in comments that we have given, especially with the external circulation and the fact that it needs to be protected. But I was hoping that you would have tried something a little more than just covering up the external circulation, because it does have other implications in terms of especially ventilation, and I'm not sure how this impacts your building performance in terms of especially ventilation, light also. So I think that's my main comment. And so my question to you is, did you think of options other than just covering the external circulation with a sort of glass enclosure?
Yes, excuse me, yeah. Actually, we considered it, but sir, the best option, because of the lighting issue and everything, we have considered using the glass panels covering up. If it were to be covered with RCC and everything, then it would have been less appropriate to our lighting structure of the building.
Yeah, Shaili, you can go next.
So guys, good job with the presentation. I also echo what Piyush just mentioned. I think you guys have done a very good job in terms of analyzing the assessment that you've done initially. I also want to kind of highlight the fact when we were going through the reports, I think your report was very, very crisp. I think it was covering all the points in a very precise manner, very strategically. But unfortunately, a lot of the supportive elements were there in the annexure. So that's one point that even the same stands true for all the other teams as well. It is very critical to pick and prioritize what should go in the main report and what should go in the annexure. So, but I think in your case, the majority of the part was in annexure. So I think in today's presentation, yes, it was like quite clear as to what all elements and how have you taken the approach to complete your entire design. So one question that I had was with respect to some of the strategies that you have proposed. So in your design, you're talking about including lighting sensors, BLDC fans, IoT-based monitoring system. But I just wanted to ask in terms of its adoptability, like how well do you think would it be, maintained by and operated by the respective stakeholders? What is your perspective on that?
Can you please repeat the question?
So I was asking, you have talked about integrating some strategies in your building, which is the use of lighting sensors and BLDC fans. These are mentioned to basically reduce your energy consumption, and as basically as one of the strategies that you are implementing. So my question was, in terms of its operation and maintenance, what is your thought process? Like how well do you think it would be integrated in the system, and how would it be operated and maintained?
For the operational system.
No worries. You can just take it as a thought. Think about it. That because sometimes there could be some questions around it, right? So just give it a thought. No worries. Second thing I wanted to ask was about the life cycle calculations that you guys have done. I think you have considered the building life to be, I guess, 10 years, if I'm not wrong. So why is it so low? Why is it 10 years?
Actually, considering the materials that we've used bamboo mats as a partition wall, and all the even ASC block. So considering all the materials that we use, it comes up to 10 years the life cycle. We had to use 10 years of life cycle to calculate the life cycle cost in 10 years period. It is due to the material.
Okay.
Okay. How much time do I have? Okay. So, good job. I mean, coming from where you are, I think you made a great job of being here on the stage. I echo basically what my jury colleagues have said. But I want you to smile a little bit. Smile. Okay, you've done a great job coming here, so that's good, and I think we should appreciate that. I just want you to go to one slide where you go to the thermal comfort, where you said it's 22 to 32. And it will also help answer Shaily's question. Just tell us how you have achieved this. That's all. How?
We have achieved this thermal comfort from...
No, you can go through all the parameters. Just tell us how you achieved it. That's all.
About the thermal comfort?
Yeah.
So the thermal comfort, it's 22 to 32 degrees Celsius. It's from the natural ventilation for of all, per annum.
That's all. What the wall construction, the roof construction, the insulation, is there anything, inputs regarding that? I just want you to tell it, express it. It may be in the next year, but I want you to express it.
Yeah, actually we have used in the bamboo mat partition as well as AAC block. Yeah, it helps in the thermal regulation because of the voids and everything. And for the bamboo mat walls, we have used a mud plaster to plaster it, which helps in cooling down of the rooms. So that helps in the thermal comfort, reducing the thermal comfort.
Okay, but the contribution from each of that, you cannot say,
Yeah, sorry.
Okay, fine. Then what is this design builder output, which is of 2021? What is it actually? Why is it so old, or? This was done in 2021, is it?
Looking onto the reports of the last 5 years, 2021 has most high humidity compared to other year.
Of that year? Okay, you've taken that particular thing. Okay. Did you have any industry partners at all?
We have.
Sir, we have. That is Architects Collaborative from Assam.
Okay. What was their contribution?
Actually, we didn't have them till D3, deliverable 3, and we just collaborated with them. But their contribution, they just helped in the in providing the reviewing our architectural design and everything. But the architectural design that we provided are done by us, the students. All the simulations, all the structural analysis were done by us. But they provided insights to all those data and everything. Thank you.
Okay, thank you.
Thank you, sir.
Thank you, team. So folks, that was our last presentation in the CRS division. Our esteemed jury panel has shown immense dedication, for assessing these entries for the last 1 month, and also today they have, put in a lot of effort to go through these presentations. And I want to thank them personally from my side for their thoughtful comments and their assessments. So thank you, Shaili, thank you, Piyush, and thank you, Isaac. And I also want to congratulate all the finalists who presented here today, because I don't think it's an easy job coming up here and giving a presentation for 20 minutes. It's not an easy job. So well done to you guys. So as the jury coordinator for this division, I've had the opportunity to see these teams submit the work. I have myself personally gone through some of these reports, and I have myself found many of these solutions to be very interesting. So I think they've done some really incredible work, and let's not forget that they have actually discovered a way to collaborate over 9 months and come up with these integrated designs. So I think that itself deserves a round of applause. So this evening, our jury members will get together to decide who should be the winner and who should be the runner-up. So we'll wait to see who that will be. So while we wait in anticipation, don't forget to head to our YouTube channel to vote for your favorite movie. So you can vote until 5 p.m. today. The voting is open. So it's up on the SDI channel. And we also have an exhibition called the Climate Smart Innovation Exhibition, where you get to see innovative building products from the industry that address climate change. So the exhibition is now open for all of you. So you can all please proceed to the multiplex area, and the exhibit area is right next to it. And for people who are online, I'll request you to stay tuned to our channel, and at 6 p.m. you will watch the exhibitors in the Climate Smart Innovation pitch their projects to bid to win the Climate Smart Innovation Award. Until then, have a great evening. Thank you everybody here for attending this session. Thank you.
The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, is so